Go buy yourself a good pair of rain boots and start stocking up on food, because a Godzilla El Niño might be on the way. If it really happens, parts of the southern United States and southern Europe could soon be hit by intense rainfall and face a much higher risk of flooding. The same goes for South America. A series of catastrophic rainstorms could flood roads and trigger huge mudslides in countries like Peru and Ecuador. While some places deal with too much rain, others may get none at all. Indonesia and Australia, for example, might experience severe drought, which could cause massive wildfires and wipe out their water supplies. Experts think El Niño could happen sometime between June and August of 2026 and stick around until the end of the year. There's even a 1 in 3 chance it could turn into a super El Niño by late fall. I mean a really intense, catastrophic version of this event that's also known as the Godzilla El Niño. The problem is, even if you're in part of the world that isn't directly affected by this phenomenon, you might see its consequences anyway. Because it can ruin crops and cause global food shortages. That makes your everyday groceries like rice, coffee, and sugar way more expensive. No one wants that, but it's not like we can avoid El Niño. It's just a natural part of Earth's climate that's been happening for millions of years. It all starts in the Pacific Ocean. And since this ocean is so huge, whatever happens there kind of ripples across the whole planet. You see, under normal climate conditions, tropical winds blow west along the equator, pushing warm surface water from South America toward Asia. As that warm water moves away, cold water rises up from the deep ocean to take its place. We call this process upwelling. But the Earth always likes to surprise us, right? So, from time to time, a cycle known as ENSO shows up and breaks those rules. This natural cycle is divided into 3 phases: La Niña, El Niño, and an in-between stage where things are relatively quiet, known as ENSO neutral. La Niña is the cold phase. When it happens, those tropical winds get even stronger than usual, shoving more warm water toward Asia. Near the Americas, super cold water from the deep ocean rushes up to the surface. This shifts the jet stream, those high-altitude winds that steer our weather further north. For the US, a La Niña year usually means a warmer, drier south and a much colder, rainier north. It also tends to make hurricane seasons in the Atlantic way more active and dangerous. El Niño is the exact opposite. It is the hot phase. This is when the tropical winds weaken or even reverse. The sea surface temperatures can reach 9 degrees Fahrenheit above their normal levels. Instead of being pushed away, all that warm water flows back east toward the Americas. This pulls the jet stream way south of where it usually is, and that changes the weather completely. Areas in the northern US and Canada stay warmer and drier than usual, while the southeast and the Gulf Coast get soaked with constant rain and flooding. El Niño and La Niña episodes tend to happen every 3 to 7 years, with each phase usually sticking around for about a year. But don't expect a fixed schedule. It happens. At the beginning of 2026, the world is watching it all unfold again. A weak La Niña is finally fading away, and little by little, it's turning into an El Niño. And experts think it could be a massive one. All the signs from the ocean and the atmosphere show a powerful El Niño pattern picking up speed as we head toward the fall. If the water keeps warming up at this rate, some meteorologists believe this event could become exceptionally strong. A super El Niño is on a whole different level. It happens when the Pacific gets so warm that it basically throws the world's weather off balance. This can lead to much more extreme weather shifts. Instead of just a little more rain, you get massive floods. Instead of a short period of dry weather, you get a serious drought. This event also pushes storms into places they don't normally go, and that ends up affecting the whole world. If you're not a big fan of summer, I have bad news. A new Godzilla El Niño is probably going to push global temperatures to record-breaking heights. It's going to be unbearably hot. The last time the world had to deal with a super El Niño was back in 2015. That year, the water in the Pacific got incredibly hot, and that set off a chain reaction of disasters around the globe. The hurricane season was unlike anything we'd ever seen. Usually we see 4 or 5 tropical cyclones in the Pacific. But in 2015, there were 16. That's insane. At one point, 3 massive Category 4 hurricanes named Kilo, Ignacio, and Jimena were all spinning at the exact same time out at sea. That was a first since we started keeping track. Luckily, none of them actually hit land. But we weren't always that lucky. In July 2015, Hurricane Dolores sent record-breaking rain into Southern California, causing over $50 million in damage. Later that same year, Hurricane Marty hit the coast of Mexico, leading to another $30 million in losses. South America was hit with way more rain than usual. Rivers in Argentina and Paraguay overflowed, forcing thousands of people to evacuate. Because of El Niño, 2015 became the hottest year on record at that time, and it brought terrible droughts. In Ethiopia, for example, some parts of the country got less than a third of their usual rain. Crops failed big time, and over 8 million people were left without enough food. So, are we going to face something that intense again? Well, it's hard to say. Most experts agree that an El Niño is in fact coming, but we're still not sure about its strength. Early data shows everything from a weak event to a record-breaking super El Niño. Scientists are watching it closely, but they need a few more months to see how it actually behaves. The El Niño is expected to show up by summer. Usually we don't feel the effects right away, but since this one is moving so fast, we might start seeing weird weather sooner than usual. One big change we can expect has to do with the Atlantic hurricane season, and that's good news for the US. Usually, the El Niño lowers the overall numbers of hurricanes in the Atlantic. That's because it creates high air pressure and stronger winds high up in the sky that basically rip the storms apart before they can grow. In this part of the US, this makes the whole atmosphere more stable, which stops small storms from powering up into giant hurricanes. But the main impact of El Niño usually happens in winter, and it messes with the snow. If you live in the northern US or the Midwest, you will probably see a lot less snow than usual. Of course, these are all just predictions based on what happened in previous years, but it's not a perfect science. After all, we never see the exact same weather 2 years in a row, and when you throw an El Niño into the mix, things get even more unpredictable. One thing's for sure. Since this phenomenon affects millions of people, experts have to keep a close eye on it every year. Seasonal forecasts for El Niño and La Niña too show how the weather is likely to change, helping authorities plan ahead for energy and water needs. This way, cities can prepare for too much rain or severe drought, and farmers know what to expect for their crops. But most importantly, weather alerts let people find shelters and get communities ready before disasters hit, and that saves lives.
So this huge volcano, everyone thought to be extinct, woke up and spat out a black ash cloud 50 miles high. That's about 9 times as tall as Mount Everest. Located in what is now Indonesia, the powerful Krakatoa had caused huge tsunamis that rocked over ships as far away as South Africa. It also changed the temperatures around the world for several years. The volcanic island of Krakatoa in the Sunda Strait was likely born thanks to another major eruption several centuries ago. It hadn't erupted for at least 200 years before 1883. So the first tremors and blasts in May of that year came as a total shock to people living nearby. Then ships sailing through the busy water passage started reporting clouds of ash above the volcano. It went quiet again for a while, but they could still see ash above it. The eruption culminated at the end of August. It was so powerful that it shattered the island into fragments. Witnesses heard the sound produced by it in Australia, around 3,000 miles away. They described the noise as the roar of heavy cannons. Some say it was the loudest sound ever heard. During the next 5 days, the pressure wave from the eruption traveled around the globe 3.5 times and was seen on barographs on different continents. Hot avalanches of ash spread down the volcano as far as 25 miles away at crazy speeds. They ruined the surrounding islands and took 36,000 lives. Tens of thousands more drowned in tsunamis that happened after the volcano had collapsed into the caldera. Over 100 coastal villages on Java and Sumatra were completely wiped out. All this made the waking up of Krakatoa one of the most devastating in the entire recorded history. The Earth's crust is like a giant puzzle, made up of massive pieces known as tectonic plates. These plates are constantly sliding against each other over the mantle, which is the molten layer beneath. Indonesia is right in the middle of the so-called subduction zone. Here, the Indo-Australian plate collides with part of the Asian plate as it moves northward. As the oceanic plate dives down, it gets heated up, and you've got the perfect recipe for a volcanic hotspot. Krakatoa had 3 peaks, each serving as an exit door for a massive magma chamber beneath it. During a previous eruption, debris blocked one of these exits, and the pressure built up beneath. When Krakatoa finally blew its top, the blast split the magma chamber wide open. The eruption led to a so-called volcanic winter. Krakatoa had sent 6 cubic miles of rock, ash, and debris into the atmosphere. They created a thick veil that surrounded the Earth. The particles scattered sunlight, and the troposphere below cooled down. The effect stayed strong for several years. The northern hemisphere experienced colder than average temperatures, and in some regions, summer temperatures didn't rise to typical levels. Southern California received a record amount of rainfall in the months following the eruption. The sky became darker in different parts of the world for years afterwards. The sunsets, for many months, turned into a spectacular show of red and orange. One astronomer supposed it was the source of the inspiration for The Scream by Edvard Munch. The painting shows exactly what the sky over Norway looked like after the eruption. It also produced a rare type of halo called Bishop's Ring and a volcanic purple light at night. For several years after Krakatoa had blown up, the moon looked blue and sometimes green. That's because some ash clouds were full of particles large enough to scatter red light, only letting other colors pass. Someone even witnessed lavender sun and night-shining clouds. Krakatoa became the first scientifically well-recorded and studied eruption of a volcano. Between the moments the first clouds of ash were seen by a ship passing by and the disastrous eruption, scientists managed to organize geological expeditions. They studied the volcano and gathered samples of volcanic rocks. It became useful for understanding volcanic activity. Krakatoa was sleeping tight until the 1920s, when some locals noticed a column of steam and debris spewing from the collapsed caldera. Within weeks, the rim of a new cone sprang up above sea level. After a year, it was a small island named Child of Krakatoa. It continues to erupt, but fortunately without serious consequences so far. In April of 1815, Mount Tambora unleashed a massive eruption, wreaking havoc on the Indonesian island of Sumbawa. It destroyed homes and claimed 10,000 lives. Another 80,000 perished because of diseases that spread in the aftermath. The following went in history as the year without a summer. Cold, wet conditions wrapped Europe and North America in an unexpected chill. It became the coldest in at least 250 years. In the summer of that year, the temperatures dropped the most. Crops didn't grow, livestock didn't survive, and famine took over Western Europe and North America. New England had snow and terrible frost in the summer months. Food prices went up. Oats for horses became a luxury. Some people say it even inspired the invention of the bicycle in 1817. Scientists used early data and climate models to see if it was all because of the Tambora eruption. They compared the data to similar years. They showed that precipitation was around the same, but the temperatures were much warmer. When they introduced the volcano into the scenario, they got the exact data for the year without summer. They say that a powerful volcanic eruption like that one increases the likelihood of extreme cold by up to 100 times. The explosion of the Toba supervolcano on the island of Sumatra around 74,000 years ago became the Earth's largest volcanic eruption in 28 million years. Parts of Indonesia, India, and a slice of the Indian Ocean got a cozy blanket made up of 6 inches of volcanic debris. It spat out a volume of rock comparable to almost 3 million Empire State Buildings. The crater it had left behind is still seen from space. All the ash and volcanic gases that sprang into the atmosphere because of the eruption partially blocked the sunlight. A severe volcanic winter began and lasted for 6 to 10 years. Some anthropologists see a connection between the Toba eruption and how limited modern humans are when it comes to genetic variety. Around 74,000 years ago, exactly when the Toba erupted, there was a population nosedive. That's why all modern humans trace their roots back to a tiny group of survivors. The Toba catastrophe theory proposes that most early humans in Europe and Asia didn't make it through the post-eruption climate chaos. Instead, a lucky, genetically limited bunch found their safe haven in Africa. But archaeological and paleoclimate records disagree with this theory. Benjamin Black from Rutgers University and his team set out to crack the code and discovered a hidden paradox. Maybe we were peering through the wrong climate lens. They ran 42 different climate model simulations, varying the magnitude of volcanic emissions, time of year of the eruption, background climate state, and eruption column height to see what climate disruptions the Toba eruption might have caused. There was a significant drop in temperatures in the northern hemisphere in the first year after the event, up to 18 degrees Fahrenheit. The southern hemisphere, where the early humans were settling, didn't go through a rough cooling that could have affected them all. The most significant eruptions that can seriously change the world's climatic patterns come from supervolcanoes like Yellowstone or Mount Toba. Luckily, these erupt very rarely, about every 100,000 years or more. Still, climate scientists study volcanic eruptions to understand and explain short periods of cooling in the history of our planet. Every few decades or so, a volcanic eruption lets out a substantial number of particles and gases. Some of them will block enough sunlight to start a brief global cooling period. Nothing like the real volcanic winter, but still felt across the globe. The next global disaster won't begin with a meteorite or a giant tsunami. The culprit might be warm ocean water. A powerful climate pattern called El Niño could develop in 2026, and it may become the strongest one in more than 100 years. In the past, a similar El Niño triggered droughts and a famine that wiped out up to 60 million people. Now, El Niño is a climate pattern that starts in the Pacific Ocean. Huge areas of water near the equator become much warmer than normal. And we're not talking about a tiny patch of ocean. That warm water can spread for thousands of miles. When that happens, weather all over the planet goes crazy. Some places get massive floods, while others stop getting rain completely. Winds shift, storms move, and seasons change. And that's exactly what might have triggered the disaster in 1876. Massive droughts spread across Asia, Africa, and South America. Rain disappeared for months, and rivers dried up. Crops failed over enormous areas. Over the next 2 years, millions of people were slowly starving. Historians think that up to 3% of the world's population didn't survive this disaster. Even today, it remains one of the most fatal catastrophes in human history. Scientists believe that the El Niño from the late 1870s may have been one of the strongest ever recorded. Now, how did they figure it out? Obviously, nobody had satellites in the 1800s. There were no weather apps or climate models or modern instruments. So researchers had to investigate the past almost like detectives. And one of the biggest clues came from trees. You see, every year, a tree grows a new ring inside its trunk. In wet years, the rings grow thicker because the tree gets more water and grows better. During droughts, the rings become thin and weak. So trees basically store weather records inside themselves. Scientists studied giant drought atlases built from tree rings gathered from all over the world, with some of those records going back hundreds of years. And they showed something alarming. Apparently, during the famine years, huge parts of the planet experienced extreme drought at the same time. Then, researchers checked old rainfall records from thousands of weather stations worldwide. Finally, they compared them with ocean temperature records gathered by sailors in the 1800s. All the evidence pointed to the same thing. The Pacific Ocean likely seriously warmed up during those years, and that's exactly what happens during an El Niño. But that one may have been way more extreme than normal. The event likely lasted around 16 to 18 months, several months longer than many other El Niño events in recorded history. That extra time matters a lot, because the longer the Pacific Ocean stays unusually warm, the longer weather systems around the world remain broken. Some regions experienced droughts for several seasons in a row. Rainfall dropped to record lows in several parts of the planet. It hit Asia especially hard. Scientists found that parts of Asia went through the worst drought in about 800 years. Crops failed across huge regions instead of only one country or one farming zone. The thing is, a drought alone does not automatically lead to mass starvation. But when huge crop failures happen at the same time as food shortages and bad transportation, millions of people can suddenly end up with no food reaching them. And that's exactly what happened during the global famine. Anyway, El Niño could explain why weather patterns broke down across multiple continents at once. Even though modern technology makes us far more advanced than people from the 1870s, we still depend on stable weather for food, farming, water, and electricity. And El Niño has the power to disrupt our planet on a gigantic scale. The most unsettling part is that the past disaster was not caused by some single freak event. Researchers believe that those conditions develop naturally, and Earth's climate system is very capable of producing something this extreme again. Today, the world is much hotter than it was in the 1870s, so if another Super El Niño appeared in the future, could droughts become even more severe? An El Niño can mess with the weather almost everywhere on Earth at the same time. One of the first big changes often happens during hurricane season. Normally, the Atlantic Ocean produces many tropical storms and hurricanes. But a strong El Niño can create powerful winds high in the atmosphere. Those winds basically tear storms apart before they can fully grow. So, places like the Caribbean and parts of the Atlantic sometimes see fewer hurricanes during strong El Niño years. But in the Pacific, it's the opposite story. Storm activity often ramps up in the central and eastern parts of the ocean. That can bring trouble for places like Hawaii, and sometimes even the southwest U.S. if storms move in that direction. Then winter hits, and this is when El Niño starts shaking things up in North America. The northern U.S., western Canada, and Alaska usually turn warmer than normal, and some areas get less snow. But it doesn't mean these regions don't have winter. Cold snaps can still show up out of nowhere. At the same time, the southern U.S. often gets wetter. A stronger jet stream, which is basically fast wind high in the sky at around 30 to 45,000 feet, pushes more storms across the south. They bring heavy rain, flooding, and cold weather to regions that are usually much drier. Other parts of the world can get hit even harder. For example, India and parts of Southeast Asia often lose important summer monsoon rains during El Niño years. And those rains are critical because hundreds of millions of people depend on them for farming and water supplies. The monsoon weakens, drought spreads fast. The Caribbean also gets much drier than normal during a strong El Niño. In some areas, there are even water shortages and crop damage. In Southeast Africa, drought conditions can become dangerous during the Southern Hemisphere summer, especially from December to February. A powerful El Niño may already be building in the Pacific Ocean right now, and some researchers think it could become one of the strongest ever recorded. Ocean temperatures in part of the Pacific are heating up fast. In some places, the water might become more than 5 degrees Fahrenheit hotter than normal. But for the planet's climate system, this difference is massive. The danger is actually even bigger than it looks. Today, we have better technology, satellites, forecasting, global communication. But our society still has weak spots. Food supply chains are actually under pressure, and many regions are also dealing with drought. Ocean temperatures have been breaking records for years. Some farming areas are becoming less stable because of the weather changes. Extreme weather events are becoming more spread out every year. A strong El Niño could pour gasoline on all of that. Scientists are especially worried about how unpredictable the weather could become over the next year. Oh, by the way, El Niño is just part of a big cycle. Normally, winds near the surface of the Pacific Ocean, called trade winds, blow from east to west. They push warm, sun-heated water toward Asia. At the same time, colder water rises up from deep below near North and South America. This is the reason why the ocean surface ends up uneven. The water near Indonesia can be about 1.5 feet higher than near Ecuador. But sometimes those winds weaken. When that happens, the warm water starts sliding back toward the east. The eastern Pacific heats up and the western side cools down. That's an El Niño. If the opposite happens and the trade winds get stronger, even more cold water rises from the deep ocean. As a result, the Pacific cools down more than usual. That phase is called a La Niña. El Niño and La Niña are basically two sides of the same system. Together, they're part of a cycle called Enzo. Usually, an El Niño lasts about 9 to 12 months, while La Niña can stick around for 1 to 3 years. But not all El Niños are the same. The classic type is called an Eastern Pacific El Niño. That's the one where the eastern side of the Pacific warms up the most. But there's another kind called a Central Pacific El Niño. In this case, the warmer water sits more in the middle of the ocean.
The Amazon rainforest is shifting into a climate that Earth hasn't seen in millions of years. Scientists looked at decades of real data and had to invent a new word for it: hypertropical. In normal human language, it means hotter droughts that last longer, hit more often, and push the rainforest past its limits. So yes, hypertropical is not a lush jungle, but extra, as you might think. It's more like a tropical forest, but stressed out, overheated, and drying out like a sponge left on a radiator. The researchers behind this say these conditions have no current analog. All this is pretty worrying since the Amazon acts like a giant carbon sink that absorbs carbon dioxide from the atmosphere and stores it in trees and soil. It's like Earth's lungs mixed with a massive storage vault. But when trees get hammered by heat and drought, they struggle to grow, they lose leaves, and simply wither. And when it happens, they don't just stop absorbing carbon, they can actually release it back and turn the system into a carbon source, which is the opposite of what we need. Sadly, this isn't a guess based on one bad summer. The team of scientists used data gathered across the Amazon for more than 3 decades. They studied how trees respond when drought hits and temperatures spike, and how the soil behaves too, because soil isn't just dirt. It's a whole living world of roots, microbes, moisture, and nutrients. When drought bakes the ground, trees don't just get thirsty. Their entire support system starts malfunctioning. The Amazon is all about the constant recycling of water. Rain falls, trees drink it. Then they release water vapor back into the air through their leaves. That process is called transpiration, which is basically the forest sweating. That tree sweat helps form clouds and bring more rain. It's like the rainforest runs its own water cycle loop. If drought weakens the trees, the loop weakens too, and then the forest becomes even drier. The last time similar climate conditions existed on our planet was around 10 million years ago. The planet and the animals living on it looked completely different back then, and ecosystems played by different rules. So, for everyone living on Earth now, these conditions are a challenge of a completely new, unknown level. What makes this feel even more intense is how scientists use drought and heat waves as a preview. They looked at how forests behave during extreme events today, because those events can act like a time machine, a quick glimpse at what normal could look like in the next 100 years. That's terrifying, because it means today's disaster seasons might be tomorrow's average weather. Like the Amazon doesn't get a bad year anymore. It gets a new baseline. And this isn't just an Amazon problem. The researchers say hypertropical forests will mostly emerge in the Amazon region. But similar conditions could also show up in parts of Africa and Asia too. When forests slip from carbon sinks to carbon sources, things will get ugly fast. It's like a feedback loop, a runaway cycle that feeds itself. The forest stops protecting the atmosphere and starts fueling the problem it used to help control. The Amazon helped keep the atmosphere stable for longer than humans have existed, and now it's getting pushed into conditions it never evolved to handle. It's not the first time, or climate type we'd better never encounter again. When Earth slammed all its land into one megacontinent, it didn't just make a bigger map, but a different planet. Pangaea created a monster monsoon system so intense it earned its own name, the Pangaean Mega Monsoon. It was like a normal monsoon blown out of proportion, feeding insane wet seasons in some regions and brutal dryness in others. It happened because one giant continent messed with winds and ocean moisture, like a giant wall in the atmosphere. This climate didn't spread rain evenly, it concentrated it. It created extreme swings, wet months that dump water like a broken fire hydrant, and dry seasons that feel like the planet forgot how to rain at all. The interior regions likely turned harsh and difficult, and coastal zones got slammed with seasonal extremes. Luckily, this climate won't come back the same way because it requires a supercontinent again. But the idea matters because it shows that Earth's climate doesn't just change from temperature, but also from layout. Rearrange continents and the whole sky starts behaving differently. During the snowball Earth period, the entire planet looked like Antarctica. Ice was stretching almost everywhere, possibly all the way to the equator. Ancient glacial deposits scientists found in places that used to sit near the tropics prove it was real. Here's the terrifying part. Once ice spreads far enough, it starts cheating. Ice reflects sunlight like a giant mirror, so Earth absorbs less heat, cools even more, forms even more ice, and the freeze feeds itself. And when all that ice melted under volcanoes released enough carbon dioxide, it likely did it violently, with extreme weather and huge chemical shifts in the oceans. Then there was the hothouse Earth that felt like the thermostat stuck on broil. There were long periods when global temperatures stayed way warmer than today. Sea levels rose and the planet's climate system behaved like it had too much momentum to slow down. In a hothouse world, the ocean expanded as it warmed, as warm water takes up more space. Ice sheets shrank, and without its natural light mirror, Earth absorbed more heat and dug itself deeper into the hot zone. Warm conditions messed with rainfall patterns and turned some regions into non-stop flood zones, while others dried into permanent drought. We should all be happy the next horrible climate scenario, anoxic events, have not happened for millions of years. But they did happen many times in the past, and may have contributed to mass extinctions. The ocean looked normal from above, but underneath, huge regions turned into low oxygen zones. Part of the ocean became stratified, meaning the layers stopped mixing properly. Warm surface water stayed on top, deeper water got cut off, and oxygen stopped refreshing the depths. Then bacteria took over, breaking down organic matter in ways that created nasty chemical conditions. Whole ecosystems collapsed, and it didn't take a meteor to trigger it. Just the wrong combo of warming, nutrient overload, and messed up ocean circulation. These events also left behind black, organic-rich sediments, like the ocean wrote down the disaster in dark ink. And the creepiest part is that the ocean anoxic events didn't feel like a dramatic explosion. They felt like a slow suffocation of the sea. After you learn about all these, some climate models from the past don't sound that scary after all. The Carboniferous Earth looked like it got trapped in wet mode. Giant swamps stretched across continents, and forests soaked the world like a sponge that never dried out. The air carried more oxygen than today, which sounds nice until you remember what oxygen does to insects. This was the era that produced giant creepy crawly legends like millipedes the size of a car. This climate also allowed to building huge coal deposits because withered plants piled up faster than nature could break them down. So the climate didn't just create scary life, but also fuel for the future. Coal formed because the planet had endless swamp forests and the right conditions to bury carbon instead of recycling it. This climate won't come back because Earth's continents, ecosystems, and carbon cycle don't run the same way now. During the early Eocene period, our planet ran warm enough that the poles didn't freeze the way they do now, and the temperature gap between the equator and the Arctic shrank. Scientists call this an equable climate, which means Earth felt more evenly warm across latitudes. High-latitude land stayed above freezing year-round in some models and evidence. Places near the Arctic were living without deep winter ice dominating everything. It didn't mean the whole world felt like Hawaii, but it did mean fewer extreme contrasts. If the planet warms enough, pole to equator differences can shrink again, and seasons can soften in certain regions. But the Earth system today has ice sheets, ocean patterns, and human-built infrastructure that never existed back then. So if low-season Earth returns, it won't feel calm. Did you know that India is building a megastructure visible from space? It's happening in Andhra Pradesh, a region home to 50 million people and some of the worst climates on Earth. When it rains here, it pours enough to cause massive floods. When it dries, it turns fertile ground into a wasteland. This ambitious construction is supposed to solve the issue once and for all. However, if this multi-billion-dollar project backfires, the consequences could be devastating. Let's see why. The second longest river in India is called the Godavari. During the monsoon season, this river acts like a fire hose that nobody can turn off. We aren't talking about a drizzly afternoon. From June to September, the sky practically unzips. The water level rises and the river transforms from a calm stream into a chaotic force that swallows entire villages in days. But that's not all. A huge amount of that fresh water goes completely to waste. It rushes past the villages and dumps straight into the Bay of Bengal. Once it hits the salty ocean, it's useless for drinking or farming. We're talking about billions of gallons of much-needed water disappearing into the sea every single year. Now, on the other hand, we have the Krishna River Basin, just a few hundred miles away. There, it's literally the opposite issue. Farmers are staring at dry cracks in the ground. They're praying for rain that never comes. And Krishna does not get strong monsoon support, and most of its water is already used up before it even reaches this region. By the time it arrives, it's more like a tired stream than a healthy river. That's why the authorities looked at the map and came up with a solution. Basically, take the excess water from the angry river and push it over to the dry river. This brings us to the Polavaram. The engineers are building a structure that's a giant machine, not just a wall. It's built to connect these two massive water systems, like running a giant pipe from the side that has too much to the side that has almost nothing. The project combines a massive earth and rock dam with a hydropower plant and a network of canals. However, the most impressive part of this layout is the spillway. It's a giant complex of concrete, channels, and support systems. It looks less like a dam and more like a fortress built for titans. It's a gigantic safety valve for the Earth. It stretches for close to a mile across, wider than 10 football fields placed side by side, and rises several dozen feet above the riverbed. It's fitted with dozens of huge steel gates, each one weighing hundreds of tons, and built to hold back walls of water until the system decides to let them go. The spillway is incredibly powerful. It has a discharge of around 5 million cusics. In simple terms, it can blast out millions of cubic feet of water every single second. That puts it in the same league as the spillway at China's Three Gorges Dam, one of the most powerful flood control structures on the planet. Engineers designed it to handle what they call a 1,000-year flood. And no, that doesn't mean you need to mark your calendar for the year 3026. It just means there's a 0.1% chance that a flood this massive will hit the valley in any given year. Why are the architects so obsessed with these safety statistics? Because the location leaves no room for error. The Godavari Delta downstream is home to millions of people. If this project backfires, meaning the dam breaches or the gates fail during a storm, it wouldn't just be a leak. It would be a human-made tsunami. The water meant to save the region would instead wipe it off the map. The construction pace of the Polavaram project matches this insane scale. In 2019, the workers on this site set a Guinness World Record. They poured 42,000 cubic yards of concrete in exactly 24 hours. If you loaded all that concrete into standard mixers, you would fill 4,000 trucks. Line them up bumper to bumper, and you'd get a traffic jam stretching for 22 miles. Even with that in mind, the project still has a way to go. It's so big that it starts to bend its own surroundings. It won't just stop or redirect water. It might change the air itself. Once the dam is complete, it will hold a reservoir so large that it'll function like a brand new inland sea. Put that much water under the Indian sun and something obvious will happen. It'll lift into the air. Day after day, the surface will turn into a giant steam engine sending moisture upward. Scientists call this a microclimate, but we call it accidental weather control. By creating a massive body of water, you change the local humidity and temperature. You're essentially installing a giant humidifier in a region that used to be dry. This is the part that makes experts nervous. What if they accidentally create a new climate problem while trying to solve the current one? Once you block a river and create a lake this big, you start messing with the heat and moisture in the air above. The system meant to control water on the ground ends up influencing the weather overhead too. Then there is the issue of moving the water. Picture the state as two giant tanks. One is overflowing and about to burst. The other is dry. The engineers are trying to connect them with a massive pipe to balance the levels before either one becomes a disaster. How are they doing this? To pull this off, they're carving out the earth, digging two massive canals, each stretching more than 100 miles. These aren't simple ditches, they're artificial rivers carved to ignore the natural layout of the land and go where engineers tell them to go. In 2022, monsoon floods slammed into the site mid-build. Water forced its way past temporary barriers and damaged critical leak control work. The crew had to stop, assess the damage, and start restoring the damaged sections. And the risks aren't just about concrete breaking. The real cost of this project is human. To build the city of water, you have to remove the real cities of people. When the reservoir fills, it will submerge nearly 250 square miles of land. That much water does not make room for anyone. Close to 200,000 people would have to be relocated. Old forests, tribal lands, and villages that stood for generations will disappear beneath the surface. This is the price of the project. So, with all this concrete and chaos, when does the ribbon get cut? Here's the twist. This project has been ongoing since the 1940s, back when the British were still in charge. The foundation stone appeared in 1980. Real work waited until 2004. It's a rare piece of infrastructure that has outlived conflicts and economic crashes, yet it's still under construction. Major parts of the main dam are incomplete. The reservoir cannot be filled to its full height, and key power systems have not been installed. Several resettlement zones also remain unfinished, which means the final stage of the project is still years away. Aside from the ambition and the scale, money is also the reason it takes so long. Early plans estimated about $1.5 billion. Today, The cost has passed $6.5 billion and keeps climbing. But is it worth the price? Depends on who you ask. For the farmers watching their fields dry out, the answer is yes. For the families watching their homes get swallowed by the reservoir, the answer is no. The latest deadline for completion is by the end of this decade, so there are no more excuses. The Polavaram project is a testament to human ambition. It's humans looking at Mother Nature and saying, "I think you put that river in the wrong place. Let me fix that for you." Will it work? And how well? We'll find out soon. Until then, the Godavari will keep flowing and overflowing while the Krishna will keep shrinking, looking like an abandoned movie set.
Hey, can you lift a truck with your hands? No? Shocker. But let me introduce you to nature's original strongman, the ocean, which casually tossed 700-ton boulders around like they were pebbles during a mega tsunami that hit Africa thousands of years ago. This wasn't just a bad day at the beach. This mega tsunami was so powerful, it made the 2004 Indonesian and 2011 Japanese tsunamis look like kiddie pool splashes. Now, to give you an idea of how terrifying regular tsunamis already are, the Japan tsunami produced waves 133 feet tall. The Indian Ocean tsunami was slightly smaller, but it took over 200,000 lives across many countries. Now imagine something way worse. You see, for a long time, scientists thought waves that big were just science fiction. But then they found these enormous boulders, massive chunks of rock, flung far inland, and did the math. It turns out only waves around 800 feet tall could have pulled off that kind of rocky vandalism. And the culprit? A volcano that literally fell apart into the ocean and triggered one of the most powerful tsunamis Earth has ever seen. Usually, tsunamis are blamed on underwater earthquakes, tectonic plates getting into slap fights. But volcanoes? Oh, they've got tsunami potential too. In 1883, for example, a volcano in Indonesia named Krakatoa erupted for 6 months non-stop until it exploded, and the explosion was heard all the way in Australia. This triggered many tsunamis, some almost 100 feet tall. Still, that was more like a toe dip compared to the full cannonball from the mega tsunami. Back in ancient times, the volcano that crumbled during the mega tsunami was huge, and it didn't just fall apart. It lost a chunk that was 10 times the size of Mount Everest. 10 Mount Everests. It was like the Earth wanted to see what would happen if we threw a mountain into the ocean just for fun. It was so massive that when the entire side of the volcano belly flopped into the Atlantic, it created waves that could cover the Statue of Liberty 3 times. It also destroyed an island more than 30 miles away. The volcano behind this real-life Michael Bay scene was called Fogo, located on, you guessed it, Fogo Island. This island is basically just a whole single volcano that rose from the sea thanks to a magma hotspot, a place in the ocean where a lot of magma escapes and erupts like an underwater volcano. Over time, this magma cooled and stacked up like pancakes until, voila, after 7 major eruptions, the island popped out of the ocean like it was playing peekaboo. Surprise, it's a volcano. But Fogo's dramatic entrance was also a ticking time bomb. You see, the more a volcano grows, the heavier it gets, and if there's not enough magma inside it to support it, the whole thing can just collapse. Sometimes it doesn't take much. A minor earthquake, some erosion, or just a poor foundation made of soft sediment can trigger a collapse. It's like a really tall guy trying to balance over a bunch of marbles. Fogo had all the bad luck ingredients: too tall, too heavy, and built on squishy ground. And it gets worse. As the volcano grows heavier, it starts squishing the magma underneath. That lava can't rise, so it just simmers down there, slowly thickening like soup left on a burner for too long. Gases build up, pressure increases, and eventually, kaboom! It's the volcanic version of eating too many burritos and then trying to hold in a sneeze. This massive pressure and imbalance can trigger what's called a flank collapse, which is science speak for oops, half the volcano just fell into the ocean. That's what happened with Fogo. Most of the volcanic islands that form this way are long gone, but Fogo is still very much alive and kicking. In fact, it last erupted in 2014 And considering that it goes off every 20 years, maybe don't travel to Fogo Island in around 2034. For the longest time, scientists believe only big, bulky volcanic islands could collapse like this. But new research says that even smaller, skinnier guys, like the Danny DeVitos of the island world, aren't safe either. The thing is that small volcanic islands only seem stable because of their small mass. It's like Danny DeVito and Arnold Schwarzenegger both slipping on the ice. Arnie's fall might cause more chaos, but Danny can still go flying. And those little collapses? Yes, they matter. Take Santa Maria, a tiny island that's about 170 times smaller than Hawaii. It has collapsed multiple times, not because it wanted to, but because it's basically standing on soggy breadcrumbs. Its foundation is loose marine sediment, and to make things worse, it's sitting right next to the East Azores Fault, where 3 tectonic plates meet up for daily slap fights. This fault is responsible for many earthquakes and even some tsunamis that happened in Lisbon in the past, so you can imagine what it's like living right above it. Every time the volcano in Santa Maria erupts and grows, it also sinks. But when a chunk collapses, it bounces back up like a buoy. This seamount to island again roller coaster means that Santa Maria has popped in and out of the ocean like a submarine playing peekaboo, and with every peak comes a potential tsunami. Another volcano with similar trust issues is Pacaya, located in Guatemala. Between 2011 and 2013, scientists spotted strange movements in the soil, tiny shifts that suggested something underneath was getting restless. Sure enough, in 2014, Pacaya erupted. Luckily, it didn't collapse, but that risk still looms, especially if magma gets trapped in it like it did with Fogo. The consequences could be explosive, literally. In fact, about 1,000 years ago, Pacaya experienced a collapse that sent debris avalanches more than 15 miles away. Since then, it's rebuilt itself like a fiery phoenix, but it could still crumble again. That's why volcanologists obsess over the tiniest wobbles. It's not paranoia if the mountain really might fall. Now you might be thinking here, okay, but that was the past. Surely that kind of ridiculous mega tsunami collapse can't happen again, right? Well, welcome to the 21st century. Islands like Hawaii, La Palma in Spain, and various parts of the Caribbean are sitting on the same kind of geological whoopee cushions. All it takes is the right combo: loose foundation, steep slopes, maybe some trapped magma, and boom, flank collapse. In fact, it's already happened recently. In 2018, Anak Krakatau, the volcanic baby of the infamous Krakatoa, lost a big chunk of itself during an eruption. It caused a tsunami, but it was more awkward than devastating, like a volcano losing its pants on stage. Embarrassing, but survivable. But that's just amateur hour compared to history's real showstoppers. Ritter Island's 1888 collapse was so intense that the island literally got shorter. It went from being more than 2,000 feet tall to a mere 460 feet. But the record holder is the legendary Latua Bay megasplash from 1958, where a 7.8 magnitude earthquake triggered a massive landslide that sent a wave taller than the Empire State Building roaring through Alaska at highway speeds. Strangely enough, only 5 people lost their lives here, but on the other hand, the destruction path it left behind can still be seen today, all the way from space. Melting glaciers and ice caps can make volcanoes collapse too. When they melt, there's a sudden decrease in pressure on Earth's crust that can destabilize entire volcanoes. It's called isostatic rebound. It's like suddenly yanking a chair out from under someone who's been sitting still for centuries. Whoops. Also, here's something you probably never thought you'd worry about on your island getaway. Some volcanic islands grow outward as lava pours into the sea, creating unstable platforms known as lava deltas. These deltas can collapse without warning, taking newly formed land, and sometimes tourists too, right back into the ocean. No pressure though, just thought, maybe you want to stay off steaming new land. So yeah, next time you're lounging on a beachy volcanic island thinking, wow, this place is paradise. Just remember, it might also be a ticking geological time bomb with a flair for the dramatic. From ancient mountain-sized cannonballs to surprise lava deltas, volcanoes have a history of keeping things spicy.
The ear-piercing sound of sirens brings your relaxing Saturday afternoon to a screeching halt. You jump out of the chair and run to the window. The sky is covered in black clouds all the way down to the horizon. The trees are nearly bent over flat from the gale-force winds. Together with the rain, golf ball-sized hail crashes into the ground, on rooftops, on parked cars. It sounds like a stampede right over your head. Car alarms are going off everywhere. Just then, crack! Huge bolts of lightning flash across the black sky. Then the monstrous grumble of thunder. Your heart jumps in your throat as you peer through the window at the sudden chaos outside. You're filled with a primal fear of the power of nature. You snap back to reality. The sirens! Gotta get to the basement! You start to turn away from the window, and that's when you see it. A massive tornado ripping along the city street. It's throwing entire motorcycles, refrigerators, and even trees like baseballs. The roof of that building starts peeling off like a Band-Aid. The twister even lifts cars and pieces of asphalt as if they're made of feathers. It seems this tornado will flatten your city within an hour tops. You finally snap out of your hypnosis and run to the basement. The sound of the city being ripped apart terrifies you as you hunker down below as low as you can. But after about 20 minutes, everything is suddenly silent. You head out to see the clouds have disappeared, and the sun's rays illuminate the street. Luckily, your house was spared, but your modern city now looks more like ancient ruins. Stop. Tornadoes never come into cities, right? Yeah, they do. This monster doesn't care where it goes and what it eats along the way. While we're at it, you can forget about the myth that tornadoes will magically stop when they meet rivers, lakes, or mountains. They just keep on going. But about that no twisters in the city thing, about 1,000 tornadoes hit the US each year. That's 75% of all the tornadoes in the world. Most of these monsters occur in a strip, okay, more like a long blob, running up and down through the middle of the country. It's an area aptly dubbed Tornado Alley, a perfect spot for these things to form. You get cold, dry air coming down from Canada, meeting warm, humid air traveling north from the Gulf of Mexico. Warm air is less dense than cold air, so it rises and creates a strong updraft. Water droplets surround it to create the funnel cloud. There you go, recipe for a tornado. Now, if you closed your eyes, spun around, and put your finger on a map of the US, the chances of your finger landing on a major city are pretty slim. If you gathered all the cities in the whole country into one area, it would only be 3% of the US's entire land. Just like your finger, the likelihood of a tornado striking in the city is much smaller than landing in a rural area. When it comes down to it, tornadoes can touch down in big cities. They just hardly ever do, thanks to sheer chance. Another surprising myth. You always see a tornado coming because, funnel cloud right ahead. Not true. The approaching funnel can be completely camouflaged in a wall of rain. You might finally see it when it's right on top of you. In this case, you'd better trust your hearing. First, tornado warning sirens go off if you're in a place that has them. Second, listen for a loud rumble that sounds like a train coming. That's a sure sign this beast is somewhere nearby. Many people immediately start heading for shelter when they see green clouds in the sky, because we all believe it's the #1 sign of a tornado coming. Don't buy it. Yes, a green sky is a sign of a severe thunderstorm that's powerful enough to produce tornadoes, but it's not a guarantee like many people see it. While we're at it, you know how movies show the ground ripping apart during earthquakes? The gaping hole that swallows cars, houses, entire cities? Not a shred of truth to this. A crack may appear in the ground with major earthquakes, but it rarely exceeds a couple feet wide. One of the most overspread myths out there is that lightning will never strike the same place twice. Tell that to the Empire State Building. It gets hit by bolts of lightning at least 25 times a year. Pretty sure nobody's picking the building up and moving it to different locations. Yes, lightning likes really tall things, and it's not shy to keep coming back. As for that old warning about your cell phone or jewelry attracting lightning, busted. There hasn't been any scientific support for the idea that personal objects with metal in them attract lightning. You still shouldn't be out and about during a storm though, cell phone in hand or not. Now, if you're looking for a tsunami and only focused on giant walls of water, you might never see one, even if it's right in front of you. Tsunamis aren't always massive tidal waves crashing into the shore. More often than not, they look like the tide is rising extremely rapidly, receding and rising again until it overspills into the city. Not that tsunamis never form walls of water, it's just not as common. Picture Earth. Are you imagining a perfect ball? Well, to resemble the truth more, squash the poles down a little. There, now you have a realistic Earth. Scientists call the Earth an irregular sphere, or ellipsoid in fancy terms. The planet rotates on its axis, causing the equator to bulge out a bit, just like what happens when you spin fast on a merry-go-round. You feel pulled out and away from the center. What's the highest point on Earth? Everest, of course. But if we go from the point furthest away from the center of the Earth, the crown goes to Mount Chimborazo in the Andes. Its peak is actually 6,800 feet closer to space than the summit of Everest. That's because Chimborazo sits near the equator, where the planet's bulge is greatest. The blue whale weighs as much as 30 elephants, makes sounds louder than a jet, and eats 4 tons of food every day. It's the largest living creature this planet has ever seen. Only, not technically. Head to the Malheur National Forest in Oregon, home to a creature that weighs as much as 20 blue whales. The honey mushroom is a humongous fungus colony united into a common system. The giant covers an area of 1,500 football fields, and it's thousands of years old. Ask anyone to draw the sun, and they'll draw a happy yellow circle. But if you look at our star from the moon or the International Space Station, you'll see that it's actually white. From Earth, the sun looks yellow or red thanks to the atmosphere acting like a filter. Most people think time is constant and moves at the same speed no matter where you are. But the speed of time depends on how close the watch is to Earth. The weaker the gravity, the faster time passes. So the person living in the apartment above you is aging faster than you. Now, it's only 90 billionths of a second faster per 1 foot higher, so don't expect to notice a difference if you decide to move to the first floor. The ground under your feet feels pretty solid and whole, but in reality, the Earth's crust is all broken up into plates surfing on oceans of liquid rock called magma. You don't feel it, but the ground under you is moving a little over ½ an inch per year. That's about the same rate your toenails grow. Largest desert in the world? Easy, the Sahara. Nope, it's Antarctica, which is almost 2 times bigger than the Sahara. A desert isn't just a scorching sandy place where it doesn't rain. It's a place with very little precipitation, so that includes snow too. In some parts of Antarctica, it hasn't rained or snowed for millions of years. In other parts, snow does fall, though rarely. Point is, there's a myth that it doesn't snow in extreme cold. Antarctica is the coldest place on Earth, and it snows there. There is some truth to this old saying. Cold is drier. It doesn't retain moisture as well. You need moisture to produce raindrops and snowflakes. That's why there are fewer chances for snowfall when temperatures drop so low.
Earth has one huge connected global ocean that covers about 71% of the planet's surface. And since it's all water, it could make sense that it's the same height everywhere in the world, right? Strangely, at the Panama Canal, the Pacific Ocean is sitting higher than the Atlantic. And it gets even stranger. In the Indian Ocean, there's a massive gravity low where sea level sits dozens of feet lower than the global average. Let's figure out the mystery of the Pacific Ocean first. The difference in height between it and the Atlantic is, on average, about 8 inches, and that's a carefully measured, long-term difference. We aren't talking about waves or high tides here. The thing is, water expands when it's warm. The Pacific is usually warmer than the Atlantic, so its water kinda takes up more space. Salinity matters too. The Pacific is less salty in many regions. Fresher water is less dense, and less dense water sits a little higher. Then there are currents and winds. Strong trade winds, which are winds that blow from east to west just north and south of the equator, push massive amounts of water westward across the Pacific. That water piles up along continental edges. But probably the most important and unexpected factor is that gravity isn't the same everywhere on Earth. Continents, islands, and even underwater mountain chains pull on the ocean's surface. And the ocean actually follows Earth's uneven gravity field, not its geometric shape. Because of all this, global sea level can vary by up to 10 feet from one region to another. Now imagine how difficult it was to fight gravity and build a canal connecting these two oceans. Engineers had to consider the Pacific-Atlantic height difference while working on the construction of the Panama Canal. Surprisingly, it turned out that it wasn't the main obstacle. There were much bigger problems, but we'll talk about them a bit later. So one day, people looked at Panama and thought, how hard could it be to dig a canal and connect two oceans? Very hard. The surface of Panama is steep, muddy, rainy, and unstable. So instead of digging in a sandbox, building a canal would be carving a trench through a wet, collapsing mountain. Engineers wanted a sea-level canal cut straight across so ships could cruise through without any locks or lifting. But Panama wouldn't cooperate. Every time workers dug into a hillside, the dirt slid right back down. During the rainy season, rivers flooded everything, burying the equipment. Then workers started getting sick constantly. At the time, scientists didn't fully understand that mosquitoes were spreading diseases, so outbreaks were literally wiping out crews. Thousands of people lost their lives. Eventually, the whole project collapsed, both financially and physically. Years later, the US tried again, but this time they decided to take nature into consideration. Instead of digging straight through at sea level, they built a giant water elevator system. It works like this. Ships enter huge chambers and the gates closed. Next, water fills in and the ships get lifted about 85 feet. That's basically the height of an 8-story building. That's where a huge artificial lake is. The ships cruise across that lake, then get lowered back down on the other side. It's like moving ships over a hill using bathtubs the size of skyscrapers. Anyway, what's the deal with Earth's gravity? Forget the idea that our planet is a perfect ball. Imagine it as a lumpy and spinning potato. The middle bulges out a bit because of the planet's rotation. The crust isn't uniform either. The density below the surface changes constantly. Some areas are heavy and dense, others light and floaty. That's what actually shapes gravity across the planet. Now, it's time for the geoid to enter our story. It's the shape the ocean would have if it were shaped only by Earth's gravity and rotation, with no waves, no winds, and no tides. In other words, if it just floated freely across this lumpy potato. Over dense areas, gravity pulls harder, so the water piles up. Over lighter areas, gravity is weaker, and the water sags. For example, there's a weird spot in the Indian Ocean where gravity is actually weaker than normal. And because of that, the sea level there sits more than 328 feet lower than the surrounding ocean. That's like water dipping down the height of a 30-story building. It forms a massive circular depression covering about 1.2 million square miles. It's officially called the Indian Ocean Geoid Low. Scientists first noticed it in 1948 during a gravity survey from a ship and have been puzzled about this phenomenon for years. Why would Earth's gravity be weaker in one patch of ocean? Finally, researchers think they might have figured it out. Deep under that part of the ocean, huge plumes of hot magma may be rising from the mantle, kind of like slow-mo lava blobs pushing upward from thousands of miles below. These upwellings can shift mass inside the planet, and when mass shifts, gravity shifts too. Lean mass underneath means a slightly weaker pull, and the ocean water sinking lower in that spot. To test the idea, researchers ran massive computer simulations. They basically rewound Earth's history back 140 million years to see how the region evolved. And guess what? Their models point to the breakup of an ancient ocean that no longer exists. Apparently, tectonic plates moved and pieces of crust sank deep into the mantle in that region. They likely disturbed the material below, setting off those magma plumes. So this gravity hole isn't a hole in the water. It's a dent in Earth's gravity field, caused by deep, planet-scale plumbing problems that started millions of years ago. The depression is so extreme that it influences ocean currents, sea level readings, and even satellite paths. That's how strong these mantle processes are, even millions of years after all that tectonic drama. The big question now is, will the Indian Ocean geoid low ever go away, or is it here to stay? Scientists aren't 100% sure. It all depends on how the masses inside Earth move around over time. Our planet's mantle isn't solid. It's constantly shifting, rising in plumes and sinking in slabs. These slow and deep motions can either keep the gravity low intact for millions of years or eventually smooth it out. Think of it like a giant slow-moving lava lamp under the ocean. Over a few 100 million years, the blob could shift enough to erase the dip, or not. In any case, the study gives some interesting ideas and might push experts to dig deeper. The older research only modeled sinking cold slabs in the mantle. Now, the simulations include hot, rising magma plumes. They were probably key to forming the low in the first place. But there are also missing pieces in the simulation. For example, the famous Réunion hotspot, a massive mantle plume that erupted around 65 million years ago, forming the Deccan Traps across India. That eruption dumped lava over half of India. It was one of the biggest volcanic events in Earth's history. Without that plume in the simulation, some of the geoid predictions might be off. There are also mismatches between the model and reality. The predicted shape of the Earth's surface doesn't perfectly match actual measurements, especially in the Pacific, Africa, and Eurasia. The researchers say there's about an 80% correlation, which is quite good, but not perfect. Unfortunately, the simulation can't capture every detail yet. The lead researcher explains why. We just don't know exactly what Earth looked like millions of years ago. Plates were shifting, oceans were moving, and continents were crashing into each other, so there's a lot we just don't know. The models can only give us a rough idea of what the past looked like. Still, despite the small errors, the main takeaway is the following. The Indian Ocean geoid low is massive and shaped by deep mantle plumes and ancient tectonic events. It might change over the next hundreds of millions of years, or it might stick around. It's also a reminder that Earth is not a perfect smooth ball we like to imagine. Our planet sure is full of mysterious, unbelievable places. But here's a list of spots that look like they came straight out of a sci-fi movie. I bet you'll be Googling them later to see if they are truly real or not. If I asked you to think of the coldest place on Earth, you'd probably say it's somewhere in Antarctica or the North Pole, right? But what if I asked you to name the coldest cities on Earth, one where people actually live? Well, think Winnipeg in Canada, which once got as cold as the uninhabited planet of Mars. It so happens that on one of its warmest days, Mars's surface temperature reached a maximum of -20 degrees Fahrenheit. That same day, stiff northerly winds made the air temperature feel like -40 degrees Fahrenheit. That meant that exposed skin could freeze in less than 5 minutes. Yeah, the same thing took place on Earth, in Winnipeg. Even in these extreme days, people have to carry out their daily activities. See those shopping bags hanging on apartment windows? Well, people use the outside air to keep some of their food frozen, since they basically live inside a mega freezer. In Winnipeg, you'll find your share of cold day experiments, like people that boil water just to take it outside, throw it up in the air, just to watch it freeze mid-throw. Yes, it's that cold. Oh well, I guess I won't be visiting anytime soon. Now, all the way down in Senegal, Africa, one bears witness to an unbelievable sight. Some 18 miles north of Dakar, the country's capital, lies a unique lake. Arriving there, you might think you're walking out of a spaceship and onto an unknown planet. After all, have you ever seen real-life pink water before? The so-called Lake Retba, or Black Rose, as known by locals, has become internationally famous for shining in its vivid pink color. And yes, you can swim there if you'd like, but you should know the water is extremely salty. Lake Retba is known to be one of the world's saltiest lakes, with a saline level of over 40%. And in case you're wondering why the water is pink, I assure you this has nothing to do with otherworldly factors. It's actually due to the high levels of salt. The algae known as Dunaliella salina is the one responsible for the pink shading. These algae produced red pigments that absorb sunlight, giving the lake its striking pink color. But if you'd like to catch the lake in its brightest color, you should go during the dry season, between November and June. In other months, the rainwater dilutes the pigments and its color becomes less distinct. Lake Retba has turned into a highly famous international attraction in recent times, since after all, who wouldn't love a picture swimming in an infinity of pink? The island of New Zealand is traditionally known for its scenic landscapes, but hidden inside a few isolated caves in the country's North Island lies a wondrous underground phenomenon too surreal to be true. To access this natural wonder, you have to descend over 150 feet through a labyrinth of caves that get darker and darker by the minute. You'll reach places of complete darkness. There, standing majestically glued to the cave ceilings, you'll see New Zealand's native glowworms. These glowworms are the larval forms of a species of fungus that are endemic to the country. They're a strange luminescent species that thrive only in the depths of the earth. Day or night, they'll be down there twinkling their blue light, hoping to attract unsuspecting prey. If you are lucky enough to tour around these caves, you'll feel like you're floating inside a galaxy, while thousands of living stars sparkle above you, reflecting their glow into the waters beneath your boat. Speaking of caves, Mexico is home to one of the world's most astounding caves, the so-called Cave of Crystals. If you think you've seen giant crystals before, wait until you check these out. Around 1910, a team of miners was digging a shaft in the outskirts of Niño, a town located in the Chihuahua province in Mexico. At around 390 feet, they found a large cave filled with clear selenite crystals. Now, jump another 90 years to the time when another team of miners dug further into the ground, reaching a depth of around 980 feet, when they found something much more surprising. It was a cave filled with impossibly large crystals, some measuring up to 39 feet long and weighing up to 55 tons. Science explains that 26 million years ago, the cave was filled with mineral-rich hot water, which allowed for the formation and growth of such huge selenite columns. The Niño crystals are believed to be the biggest ones in the world, making a human that stands beside it look like a very tiny creature. Oh, and speaking of standing inside the cave, conditions there are far from welcoming to us humans. Temperatures reach 136 degrees Fahrenheit, and the air is filled with 99% humidity, making it extremely difficult to breathe without the help of protective gear. And even so, a person can only last up to 20 to 30 minutes down there. The Quang Sai Falls, which are located about 18 miles south of the city of Luang Prabang in Laos, is a complex waterfall formation. Because of the bedrock in the region, the waterfall was developed in a highly unusual way. It's a three-tiered waterfall, which is at first a series of shallow pools on the cliff edge that ultimately lead to the main fall that has a drop of around 200 feet. As soon as you see this place, it becomes clear why it's one of the most popular relaxation spots for tourists in the country. The water is clear and turquoise, and virtually every angle makes for a perfect photo op. Beyond the falls themselves, the area is covered in lush green vegetation and has a wide tropical jungle to explore. It has been deemed one of the most astonishing waterfalls in the world. Mauritius is known for its idyllic beaches and crystal clear sea, but there's an unbelievable phenomenon at the southwest corner of the island that appears to be an underwater waterfall. Despite how it looks, this isn't a flowing region of water. but instead an optical illusion that happens because of the seafloor structure. The island sits on an ocean shelf that is no more than 500 feet deep. At the edge of the shelf, however, it soon plunges to depths of 2.5 miles. So what you're seeing there is not an underwater waterfall, but rather you're witnessing particles of sand that are being pushed over by the current. I'd say a boat ride over that area would be rad. Now this next sight will either give you goosebumps or make you marvel at its weirdness. I'd say it depends on the time of day you visit. Next to the small town of Gryfino in Poland, you'll find a very unusual sight, a pine tree forest where each tree is bent at its base. If you visit the crooked forest during the daytime, I'm guessing you'll be fascinated by these sharp 90-degree curves. No, you can't use their trunks as a stool if you decide on having a picnic, but that would be cool. Visiting the site at night will most likely give you constant chills. There's a thin layer of fog that hovers around, making the forest seem quite unwelcoming. And then, there's the fact that science still can't explain why the trees are the way they are. Madagascar is usually thought of as a place with unparalleled amount of biodiversity, but its geographical features are equally impressive. The Stone Forest, which is located within the Singi Debamara Nature Reserve, began life hundreds of millions of years ago as a lagoon. Today, with the help of erosion, you'll find a series of towers with deep canyons between them. The reserve is huge, stretching over 375,600 acres. But it's the height that gets scary. Some of the rock's pinnacles can stretch up to 500 feet high. In the local language, Singi means where one cannot walk barefoot. The word refers to the tall, needle-like rock formations that can be found throughout the reserve. So, if you ever do go visit, make sure to have some high-quality hiking shoes on you. Right now, tiny dust from deserts far, far away might be secretly changing our whole climate, likely making it way cooler. Scientists have found that strong winds carry those particles and they can travel thousands of miles through the air. Eventually, they end up in the sky, inside clouds. And once they're there, they start to change the way clouds behave. Try to think of clouds like giant mirrors in the sky. They reflect sunlight back into space and help control how much heat stays on Earth. But when you add dust into the mix, everything gets messed up. The particles act like tiny triggers that make water droplets freeze into ice, even when the temperature is only slightly below freezing. It might sound harmless, but it's not. When clouds freeze, they begin reflecting sunlight differently, and they also change how rain and snow form. So something as small as dust can affect how much heat the planet keeps and how much it loses. A team of researchers from ETH Zurich used 35 years of satellite data to figure out this phenomenon, and they found a clear pattern. When there was more dust in the air, clouds were much more likely to freeze at the top, especially mixed-phase clouds. Those are clouds that contain both liquid water and ice at the same time. They form at temperatures between about 32 degrees Fahrenheit and negative 38 degrees Fahrenheit. They're super common across the northern hemisphere, especially over places like the North Atlantic, Siberia, and Canada. These clouds are very sensitive. It doesn't really take much to push them from mostly liquid to mostly ice. All you need is just a bit of desert dust. Well, it's just one of the factors, but an important one. Scientists have been studying how tiny water droplets freeze for years, usually in labs. They examine things so small you need powerful microscopes to even see them. We're talking about structures measured in nanometers. That's about 0.000004 inches. And now we observe the same behavior, but on a massive scale. Those tiny dust particles are affecting clouds that stretch for miles across the sky, big enough to be seen from satellites orbiting Earth. When scientists started looking at dust levels and what clouds were doing, they spotted a clear pattern. More dust plus colder air resulted in more ice forming in the clouds. But the most worrying thing is that it's not just happening in one place. This is going on across huge areas, and it's really hard to predict how it will affect the climate. What we know is that frozen clouds drop rain and snow way more heavily than usual. So storms can get stronger and snowfall can get way more intense across huge parts of the northern hemisphere, from regular climates all the way up to polar regions. So basically, these tiny invisible dust particles floating in the air could be setting things up for massive, unusual storms. And we don't fully understand this process yet. I mean, how do you even track how much dust is flying out of deserts every single day? Scientists say that if this keeps happening, things could get really extreme. Storms, heavy snow, and weird weather could start happening more often, and no one will be able to predict where or when. But it's not the same everywhere. In places like the Sahara Desert, for example, there aren't many clouds to begin with. That's why the hot, rising air can actually make freezing less likely. In the southern hemisphere, things work differently too. There, sea salt and particles from the ocean might play a bigger role than desert dust, so the picture isn't that simple. Scientists still need to figure out how other factors come into play, like how fast air moves upward or how much moisture is in the air. All of these things can change how clouds freeze. But if you're worried that dust will make our planet colder, you should probably know that, technically, we're still living in an ice age. You see, this ice age started about 2.6 million years ago. It's called the Quaternary Glaciation, or the Pleistocene Ice Age. Right now, we're in a warmer break inside it, which is called an interglacial period. But about 650,000 years ago, the world looked very different. Huge animals like mammoths and mastodons roamed across North America, and not far from them was something even more massive, a gigantic sheet of ice, in some places almost 2 miles thick. That's taller than most mountains you can see today. This ice covered most of what we now call Canada and stretched down into parts of the United States. Then the planet warmed up, the ice slowly pulled back, and places that were once buried under ice, like modern-day Quebec or Chicago, became livable. But the ice didn't go away completely. Even today, massive ice sheets still sit on top of Greenland and Antarctica, and they hold an unbelievable amount of water. If all that ice melted, sea levels could rise by hundreds of feet. Entire cities would disappear underwater, and in recent decades, these ice sheets have started melting faster. Are we heading toward a world with no ice at all? The real end of the ice age? Most scientists don't think everything will melt anytime soon, not within this century. But even a tiny change could still be a huge problem. Some estimates suggest sea levels could rise by up to 3 feet. Doesn't sound like much, right? But even 1 or 2 feet is enough to flood coastal areas and force millions of people to leave their homes and move inland. And that's why scientists are trying to get more precise answers. Now, speaking of ice ages, there's some sort of connection between them and that pesky dust that seems to be cooling our planet. You see, there are glacial periods when things get really cold. They can last tens of thousands of years, and huge ice sheets spread across large parts of the planet. Then there are interglacial periods, like the one we're in now. These are warmer breaks that usually last only a few thousand years. The climate during these times feels a lot like what we have today. But what causes these big shifts? Scientists are still trying to figure it out, but one of the main factors is simple: sunlight. It all depends on how much sunlight Earth gets, and that changes over time because of several things. First, the tilt of our planet. Sometimes it leans more, sometimes less. Second, the wobble. Earth doesn't spin perfectly straight, it wobbles a bit, like a spinning top. Third, the shape of Earth's path around the sun. Sometimes it's closer to a circle, and sometimes it stretches into more of an oval shape. And finally, it might be how much sunlight the clouds over our planet reflect. That's where the desert dust comes into play. Over thousands of years, these small changes add up. They can change how much sunlight reaches certain parts of the planet, especially the northern regions near the North Pole. When less sunlight reaches those areas, temperatures drop, more water freezes, and ice sheets start growing. That's how an ice age begins. When more sunlight reaches the same regions, the opposite happens. Temperatures rise, ice melts, and the planet moves to a warmer phase. But it's not just sunlight. There are other factors too, and scientists are still piecing them all together. To understand what happened in the past, researchers study ice cores. Those are long cylinders of ice drilled out of glaciers. Layer by layer, they store information about Earth's climate going back hundreds of thousands of years. What they show is pretty exciting. During this current ice age, Earth has switched back and forth between cold and warm periods at least 17 times. And it's very likely that the planet will turn cold again someday, maybe already in a few thousand years. But now there's a new factor in the mix: humans. Our activity makes it harder to predict the next ice age.
When you think of an epic desert scene with blazing sun, endless dunes, and those magical little oases, you probably picture the legendary Sahara, right? But what if I tell you that 11,000 years ago, this vast expanse of hot sand looked totally different than it does today? Yeah, I don't know, I wasn't around then. But I'm told that back then, what we now call a desert was a lush paradise, brimming with lakes, rivers, grassy plains, and even woodsy forests. So, where did all this water go? There are many stories about the distant past of our planet when deserts were covered with jungles and forests. And then something happened, like changing climates or colossal earthquakes, and it all turned green lands into dunes. But how about a theory that Sahara became a desert because of humans and goats? The Sahara has seen its fair share of wet and dry drama throughout the ages, mostly thanks to little shifts in Earth's orbital tilt, causing variations in how much solar radiation hits the atmosphere. There were even times called the African humid periods, when the rain would pour in and transform the dry landscape into a bright green haven. But between 8,000 and 4,500 years ago, something really funky happened to this region. Certain areas went from humid to dry way too fast to explain it by just orbital changes. In the blink of an eye, the lush Sahara turned into the Sahara we know today. Now, if you ask scientists why it happened, they will tell you, oh, it's just poor parameterization of the data. Bet you didn't get it, did you?
What?
Well, right, let me translate it from scientific to common human. It means they really don't know the answer themselves, and they got a bunch of missing puzzle pieces. But as scientists sifted through ancient dirt and pollen samples, they spotted a quirky trend. Wherever there were pastoralists, also known as humans with their domesticated animals, the plant life seemed to shift. It was as if every time humans and their furry friends meandered through the greenery, they turned it into scrub and desert right behind them. Oops. Yep, chances are that by overgrazing, humans were sapping moisture out of the atmosphere, since plants give off moisture, which helps make clouds and making things even sunnier, leading to a quicker end of the humid vibes. Plus, our ancestors may have been getting a little too cozy with fire for land management, further speeding up the desert takeover. Anyway, scientists are sure that this lush Sahara would have turned back into desert eventually, even if humans hadn't shown up, thanks to Earth's natural rhythms. So there's no need to pin this abrupt change solely on humans. It could simply be about nature getting feedback from vegetation and dust cycles. It's difficult to determine what caused these changes, as it's all interconnected. During the last humid period, the Sahara was filled with hunter-gatherers. As things got a little drier, they started herding animals for food. The weather pushed people to herd cattle. It's also possible that grazing sped up the landscape degradation. So, which came first, the chicken or the egg? Or in this case, the human or the cow? It's tough to tell with the evidence we have now. Now today, it's safe to say that water is no longer that big of a problem in the Sahara, even though it's a huge desert and the times of lush forests there are long gone. But technology's got us covered. For example, the Nubian Sandstone Aquifer System, the biggest underground water stash on the planet. It's nestled beneath the Sahara Desert's eastern edge and stretches across 4 northeastern African countries – Sudan, Chad, Libya, and Egypt, covering a whopping 770,000 square miles and holding around 36,000 square miles of groundwater. Just look at the pipes transported when it was being built. It's the world's largest irrigation project. No wonder it's feasible to thrive in the Sahara today. But imagine thriving in the Sahara Desert with just one water source. Sounds like a tough gig, right? But the ancient Garamantes did just that, surviving and even thriving for nearly 1,000 years without monsoons or rivers flowing to their desert paradise. These clever folks were the trendsetters of urban life in the sands, and even the Romans couldn't help but notice their genius. While many thought they were just desert-dwelling savages, the Garamantes were busy building an empire in one of the toughest climates on Earth. But how did they do that? Well, they got crafty and dug a whole bunch of underground tunnels to tap into a massive sandstone aquifer. They were literally squeezing every drop of life from under the dunes. But recently, research showed that the Garamantes weren't just hardworking, they were pretty lucky too. The Garamantes had an underground aquifer that brought water up to a hill where they built over 500 fogaras, which are irrigation systems, some stretching as long as 2.5 miles. It was like sipping water through a straw, which let them irrigate their crops for nearly a century, especially since even a little rain would help recharge the system. But eventually, due to rain insufficiency, the aquifer ran low, and reaching it again would have meant digging more tunnels and relying on more people. That's a tough problem, considering these people were in the middle of food and water shortages. Guess I don't need to tell you what happened to the Garamantes, do I? The fall of the Garamantian culture might be linked to several factors. It may have been due to climate changes, or they may have simply used their water resources too much. Back in the day, the Sahara Desert was actually fertile agricultural land, thanks in part to the cool irrigation system the Garamantians created. But since fossil water isn't something you can replenish over time, the groundwater levels dropped pretty low. This likely played a big role in the kingdom's decline by the late 7th century CE. That sounds like someone who hit a lottery jackpot, used up all the money, and went back to their original not-so-cool job once the bank account got fully drained. Oh, by the way, even if the Garamantes left some secret wisdom messages for us, the chances are we'll never get what they wanted to tell us. Nobody really knows what language they used, and their texts are nearly indecipherable to us today. But let's go back to the Green Sahara. So it transformed into a desert about 4,500 years ago. But today, we can understand how people lived in those times in the Sahara thanks to natural parks in Africa that have the ultimate outdoor art gallery. There are well over 15,000 ancient paintings and carvings depicting everyday life from around 11,000 years ago. However, if the carvings aren't enough for you and you feel like visiting an actual green desert, all you have to do is book a flight to California. One of the most beautiful phenomenon in the world, the superbloom, takes place here. Look at all these colors – orange, green, pink. It's a miracle. Wildflowers bloom right in the middle of a hot desert after several years of rainfall in dry places. It's such a bright and colorful landscape that superblooms can be seen from space. This rare phenomenon can be observed in other arid places and deserts in western and southern Africa, Western Australia, and Chile. In all these places, the weather is very hot and dry in summer. Mild humid air comes in winter, and this is the ideal environment for mass flowering. Flower seeds that lie in desert sands can wait for decades before starting to produce flowers. When the hot sun destroys all the weeds and grass, and the rainfall becomes enough to moisten the soil, the seeds are kind of like, well, okay, now it's our turn to play a big game. And then hundreds of thousands of tourists come to take photos and post these beautiful pictures on social media. And this, unfortunately, is one of the main dangers for flowers. Therefore, if you find yourself in a place like this, don't pick the flowers and don't trample on them. Stay on the path, don't litter. Take only pictures and leave only footprints. You get it? Good. So the Sahara Desert is so big that it covers 8% of the world's territory. It's bigger than the USA or China. Surprisingly, the Sahara is not the largest desert in the world. It is the third largest, behind Antarctica and the Arctic. But it is definitely the hottest one. Temperatures there reach 136 degrees Fahrenheit. This place has some of the most incredible sand dunes you've ever seen, towering up to 1,476 feet. But here's the kicker. There's a real risk that these dunes might continue to spread until they cover the entire world. Surprisingly, the influence of the Sahara Desert extends far beyond its borders. Its dust, carried by powerful winds, makes its way to the UK and across the European continent, particularly in winter. This dust, settling on the ground where it rains, is a familiar sight to those in the UK, often leaving a red residue on cars. This connection between the Sahara, England, and Europe serves as a stark reminder of the global reach of environmental phenomena. You might think this is not a big deal, but it could turn Europe into a desert, leaving its soil infertile and Europeans with no food. Soil is a fundamental aspect of human existence, just as crucial as clean water and air. Without it, we're left with nothing but a bleak and barren landscape. The Sahara Desert has already made its jump across the Mediterranean Sea, which is concerning and could change the landscape forever. 1/5 of Spain has already turned into a desert. The next victim is Italy, which also faces the problem of desertification. In fact, almost all European countries have the same issue. According to an expert, the land that has not changed for nearly 2,000 years will become mostly rock, and people living on this land will be gone. 60% of the soil in Moldova is gone, and the problem has expanded beyond the Black Sea. It has reached China and Mongolia, thousands of miles away from the Sahara Desert. All of this causes losses of $4 billion a year. The threat is so significant that even the UN has gathered the necessary resources to solve the problem as soon as possible. Italy is sending help to Africa to stop the Sahara Desert from expanding. If this process does not stop in the next 10 years, millions will be forced to leave their homes. The Sahara Desert is growing for approximately 30 miles per decade. You do the math and see how long it will take to cover Europe. Since 1920, the Sahara has expanded by around 10%. But not all hope is lost because more than 172 countries have joined to put a stop to the desertification of the world. The World Food Program is a project that aims to help bring back green land that was once present in the Sahara. When they told people who called the Sahara home what they were about to do, the latter basically laughed in their faces and said it was impossible. But when you have a specific goal in mind, the impossible becomes possible. If we traveled back around 5,000 years into the past, we would see a beautiful forest with lush green trees and grass. Africa's climate has been changing for 21,000 years, from fantastic greenery to uninhabitable deserts. This has to do with Earth's rotation and the monsoons that bring water to this dry continent. But with the help of scientists and some clever tricks, we can bring the greenery back and stop the Sahara in its tracks. The Senegal River serves as a border between the Sahara Desert, Senegal City, and Mauritania. When you look at this area from space, you'll see how the desert is expanding to Senegal because the vegetation along the riverbank is almost non-existent. Forests can serve as a barrier, stopping the sand from getting blown away and the desert from expanding. An effort to create a great green wall is being made, and how they do it is actually quite impressive. Nothing has been growing in the currently restored area for more than 40 years, making locals find other places to call home. People were thrilled when they saw that the land could be restored. They're very committed and learn to work with the soil and grow food. At the same moment, more than 30,000 hectares have been restored and transformed into lush greenery. The Sahel region is the starting point of desertification, and it is crucial to establish a green wall in that area first. To make this wall is not rocket science, since it only takes a few simple steps. The ground there is baked by the sun and as hard as a block of concrete. If you've ever poured water on concrete, you know that it just flows away. It doesn't stay in one place. So they had to create water-retaining half-moons that would hold the water and make it available to plants. When you learn about how these half-moons work, you might say, How did they not think of that sooner? Actually, this technique is ancient, and it was once implemented in Sahel, but it was lost over time. When the rain falls, the water is collected into the half-moons that are positioned a bit lower than the ground below contour lines. There is also a kind of bank at the end of the shape that prevents water from overflowing, and in the middle, there are plants that are happy because they have plenty of water to thrive. Also, it's essential to grow native plants that are kind of used to harsh conditions, like sorghum and millet. These plants have been surviving there for thousands of years and produce a good amount of biomass, which means the land can be rehabilitated faster and people will have food sooner. The water that will enter the half-moons won't be lost. It will penetrate the ground and top off underground waters. This will ensure the ground that H2O will never run out and that future generations will have usable aqua. This brilliant planting technique is not limited to half-moons. People also create lines and plant various vegetables, such as tomatoes. Next, there are places only for trees, like lemons or oranges. After a long hot day, nothing is better than a freshly made cold lemonade. The trees will also protect the soil, and with some luck, there will be a new forest in the Sahara Desert. The goal is to copy the forest dynamic. Start with small plants and gradually expand to bigger plants that are more useful than the tiny ones. They are aiming to plant more than 10,000 trees. Right now, many people are leaving the Sahara after the rainy season, going to cities or leaving Africa altogether. At this time of year, villages are like ghost towns. Only animals can be found there. Most people are gone. I mean, who would blame them? Nobody wants to live in the sand where nothing grows. Luckily, with all this new, old technology being developed, many people are slowly but surely returning to their land and starting to work in agriculture. The best thing is that there are no brutal winters, so plants grow 12 months a year, and people can always have food. People are becoming more social because now everybody stays in their villages and doesn't travel much. If this project works out, Africa will be saved, and the world won't turn into a giant desert. A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave, but the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600 before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake with an epicenter southwest of Cape St. Vincent triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with two more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers. Because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as tsunami ready by UNESCO doesn't mean a community is tsunami-proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault, beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteotsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe.
We know more about space than we do about the ocean. We know more about the ocean than we do about the Earth's core. But how do we study something that lies more than 1,000 miles beneath our feet? Oddly enough, you need to fly into space. Thanks to satellites orbiting the planet, scientists have discovered something strange at the very heart of the planet. News about mysterious signals from space barely surprises anyone, but how about this? We detected strange signals coming from deep beneath our own home. Before we go into those signals, we need to understand why it's so important to study what's inside the planet. How does the core affect us? Our lives depend on it in several crucial ways. First, the core plays a fundamental role in gravity. We don't drift off into space because a massive spherical mass of molten metal locks us to the surface. Second, it powers Earth's magnetic field. Dangerous cosmic radiation and solar wind that could scorch everything are blocked thanks to the planet's magnetic field. And third, the inner processes of the Earth influence earthquakes and volcanic eruptions. Any disturbance inside the core and mantle can change life on the planet. And recently, scientists recorded something unusual coming from down there. At the beginning of this century, the United States and Germany launched a mission called GRACE, the Gravity Recovery and Climate Experiment. At first, this project used 2 satellites to track how water moved around the planet and how glaciers were melting. But the satellites could also measure Earth's gravitational field. If gravity was slightly stronger or weaker in some region, one of the satellites would be pulled toward that spot, and the other would measure the change in distance. In very simple terms, the heavier something is, the stronger its gravitational pull. In certain parts of the planet, gravity can be slightly higher because of large geological shifts, ocean currents, or melting ice. But between 2006 and 2008, the GRACE satellites detected a strange change in gravity along the coast of Africa. Melting ice, water movement, and other natural phenomena couldn't explain the anomaly. No one knew what it was at the time, but years later, scientists suggested that the nature of this signal was coming from the Earth's core. Researchers noticed that some minerals, like perovskite, can undergo a phase transition when exposed to enormous pressure and extreme heat. And there are many perovskites lying in the upper layers of the mantle. When the internal structure of this mineral reshapes, it becomes denser and shifts the surrounding rocks. Deep underground, this harder, solid part moves the softer molten rock. These movements reach the molten outer core and slightly deform it. This deformation inside the core alters the flow of molten iron, and this deep current of liquid metal directly affects Earth's magnetic field. That's why satellites recorded those fluctuations. So how does all of this affect us? We launch satellites, we use compasses, we rely on GPS. All of this works only because gravity and the magnetic field are stable, and both depend on the core. That's why it's so important to study the Earth's heart. And to do that, we don't need to dig thousands of miles. Movements on the surface can reveal what is happening inside. Studying vibrations in the crust, recording gravitational shifts, calculating, modeling, and forming hypotheses. It all sounds a little boring. Is there another way to figure out what's happening down there? We sent Voyagers into space, and some of them have already left the solar system. We descend into the depths of the Mariana Trench inside bathyskiffs. So what's the problem with drilling a shaft deep into the Earth's crust? Humanity actually has some experience with this. In the 1970s, Soviet geologists began drilling the Kola super deep borehole. It became and remains the deepest artificial borehole ever created. Its depth reaches 7.6 miles, deeper than the Mariana Trench and higher than Mount Everest. More than 50 years have passed, and humanity has not gone deeper than 7.6 miles. And do you know where the Earth's core begins? At about 1,800 miles down. That's almost 7 times farther than the distance to the International Space Station. To reach the core, we would need to drill a hole 230 times deeper than the Kola Super Deep. But that project was shut down in 1992, and the borehole was closed in 2005. What stopped us from digging deeper? First, the density of the rock. In the early stages, the drill easily cut through granite, but around 4.3 miles down, the rock became much harder. The drill broke several times. Workers had to change the drilling direction to pass through softer layers. Eventually, the borehole shape looked like a string of lights hanging on a Christmas tree. Another problem was heat. The deeper the engineers went, the hotter it became. Scientists expected that past a depth of 10,000 feet, the temperature would be around 212 degrees Fahrenheit. In reality, the harder they worked, the worse it got. Eventually, it reached 356 degrees Fahrenheit. The hottest place on Earth is the Sonoran Desert along the Mexican-US border. Temperatures there can reach 177 degrees Fahrenheit. That's twice as cool as inside that terrifying borehole. And the challenges did not stop there. At a depth of about 14,800 feet, the rock became porous. The extreme heat gave it a strange plasticity. Instead of solid stone, the drill had to cut through something more like hot, softened material that was almost impossible to drill. On top of that, the stability of the shaft became a danger. At such depths, the walls could collapse at any moment. To drill deeper, humanity would need completely new technology, a drill capable of working at 500 degrees Fahrenheit. That is the temperature scientists expect in the upper mantle, located just beneath the crust. And to reach it, we would need to drill 25 miles down, almost 3 times deeper than the Kola Super Deep. There are many rumors about what the engineers supposedly discovered in that hole. The most popular claim is that they heard the screams of thousands of people who were stuck in the fiery underworld. Other fake stories claim that the workers went insane after seeing something horrific at the bottom, and that's why the project was stopped. But if we ignore these myths, what did scientists actually find? They learned that the existing temperature model of Earth's interior was wrong. It was far hotter down there than expected. Geologists thought they would find the so-called Conrad discontinuity, a transition from granite to basalt. They found no such boundary. The real discovery was a liquid at incredible depths. Scientists found cracks filled with briny water. This changed our understanding of the crust. People used to believe it was completely solid, but now it appears full of fractures and channels through which water can move. Where did it come from? Geologists think the fluid was squeezed out of the rocks by enormous pressure, as water is wrung out of a sponge. But the most astonishing discovery was life. At about 4.5 miles down, engineers found ancient fossils of single-celled marine organisms. They were nearly 2 billion years old, and they had survived at such extreme heat and pressure. Let's imagine that one day we actually reach the mantle. What would that give us? What would we expect to see? We would finally understand how Earth formed billions of years ago, how the core, mantle, and crust developed, and how plate tectonics works. We'd know how the plates push and pull against each other. We'd gain a deeper understanding of earthquakes. Researchers also hope to find extremophiles. These are primitive organisms that can withstand extreme heat and pressure. If we discover life near the mantle or even within it, scientists will study it closely and try to understand how it manages to survive under such brutal conditions. If we learn what keeps life alive in the most hostile environment beneath our feet, we might learn how to protect life in other extreme places. From the depths of the ocean to distant planets, studying the heart of our planet could reveal technologies we can barely imagine today. Our future might depend on the mysteries hidden beneath our own world. It's official. Official. A day will no longer last 24 hours. Earth's now spinning faster, literally, and our days are going to get shorter. At the moment, it's believed that the shortest day happened on July 10th, 2025. It was shorter not by much, just a fraction of a second, 1.36 milliseconds according to most sources, but still. And all because of the moon's position messing with Earth's rotation, just enough to speed things up. If it turns out to be not a one-time thing and Earth keeps spinning faster, it could be the start of a big mess. All our time stuff like GPS, the internet, atomic clocks, even how countries keep time, depends on the day being 24 hours. But if the planet speeds up, those systems could totally freak out. Clocks would get all out of whack, and anything that needs perfect timing could go sideways. We're talking about more than just a few lost seconds. This could shake up everything. Flights, money transfers, basically how we live day to day. We'll have to rethink how we measure time. Are you ready for that kind of chaos? Now, normally a day is 24 hours, or 86,400 seconds, because that's how long it takes for the planet to do a full spin. But Earth's rotation isn't always stable. A bunch of things influence it, like where the sun and the moon are, or how the planet's mass is balanced. Earth is like a giant spinning top, and anything can throw it off rhythm. But our planet has been slowing down for a long, really long time. Because according to scientists, about 1 to 2 billion years ago, a day only lasted 19 hours. Not because the planet was lazy or anything. Nope, it was the moon's fault. It was way closer to us back then. Its gravity had a stronger pull, and that made Earth spin faster. And that faster spin meant shorter days. The thing is, the moon is slowly drifting away from Earth, and as it does, Earth's rotation slows down, and our days get longer over time. But during that billion-year window, something weird happened. The moon kinda just hovered at a certain distance. It wasn't moving out, it wasn't pulling harder. It was like it paused. And that pause locked us into 19-hour days for what scientists are now calling a boring billion. It was a time when pretty much everything on Earth slowed down. Tectonic activity was stable, the climate wasn't doing anything weird, and even life kind of plateaued. Now, let's get into the sciencey part. The moon's gravity controls our ocean tides. That's what slows down Earth's spin. But the sun pulls on Earth too, just in a different way. When sunlight hits Earth's surface and heats it up, that creates what's called solar atmospheric tides, and those can actually speed up Earth's rotation. Right now, the moon's gravitational tides are about twice as strong as the sun's atmospheric tides, which means the moon is in charge when it comes to Earth's spin. But back in the boring billion, the sun and moon were basically in a tug-of-war with equal strength. This phenomenon is called tidal resonance. It's like Earth hit a cosmic pause button. If the moon hadn't backed off, we might still be living in a 19-hour day world right now. These days, the moon is still drifting away from us, and because of that, our days are slowly getting longer. Until lately, things have gotten weird. In the last few years, scientists noticed that Earth hasn't been sticking to schedule. In fact, it's been spinning faster, and I mean record-breaking fast. Back in 2020, Earth started picking up the pace more than it had since scientists started clocking it in the 70s. Then came July 5th, 2024, the shortest day ever recorded. We lost 1.66 milliseconds. Not a big deal if you're just watching videos on YouTube, but on a planetary scale, it's kinda huge. Now, we get back to July 10th, 2025. On that date, the moon was sitting way up near the poles, very far from Earth's equator. And that changed the game. When the moon is hanging out closer to the poles, it messes with Earth's rotation and makes our days a little bit shorter. That kind of change isn't unusual. Earth's spin has always had some ups and downs. But today, the moon isn't the only factor. According to NASA, human activity is changing how Earth spins too. Between 2000 and 2018, moving ice and pumping groundwater around the planet shifted enough mass that it added 1.33 milliseconds to our days per century. Natural disasters can mess things up too. Remember the massive earthquake that hit Japan in 2011? It actually shortened Earth's day by 1.8 microseconds. Just one quake, one microjolt to the planet's schedule, but the consequences were catastrophic. On March 11, 2011, at exactly 2:46 p.m. local time, a huge earthquake hit off Japan's east coast. We're talking magnitude 9, one of the biggest quakes ever recorded. The epicenter was about 80 miles from Sendai and over 230 miles from Tokyo. Japan's main island shifted 8 feet. Yes, the ground moved and whole cities literally slid, but it didn't just shake buildings and trigger a tsunami. The quake was so strong it redistributed Earth's mass, like shifting weights around on a spinning top. When you do that, the top spins differently. Same deal with Earth. The movement of tectonic plates was enough to tweak the whole planet's rotation. The thing is, the earthquake moved land and shifted Earth's figure axis. That's the axis our planet's mass balances around, by 6.5 inches. That's separate from the north-south spin axis, which we rotate on daily at about 1,000 miles per hour. But still, that shift was enough to make Earth wobble differently as it was spinning. It didn't tilt the entire axis in space. Only stuff like the sun or moon's gravity can do that. But it was still a major shakeup, no pun intended. And it wasn't the first time this had happened. The 2004 Sumatra quake, a staggering magnitude 9.1, sped up Earth's spin and cut 6.8 microseconds off the day. Chile's 2010 quake took off another 1.26 microseconds. Every time one of these megaquakes hit, it's like Earth gets a tiny jolt, spinning just a hair faster. And it might not be over. For example, that March 11 quake unleashed more than 80 aftershocks that were magnitude 6.0 or higher. Long after, some of those aftershocks were still tweaking the day length. It was very subtle, changes in millionths of a second, but real. But the thing is, even the seasons can mess with how fast Earth spins. A geophysicist from the University of Liverpool has explained it like this. There's way more land in the northern hemisphere than in the south. So, during northern summer, trees grow leaves, and that leaf mass moves upward, farther from Earth's center. And it sounds pretty harmless, right? But no, that tiny shift actually slows down our planet's spin, just a bit. Think about a figure skater, arms in, they spin faster. Arms out, they slow down. Same with Earth. When its mass shifts away from the core, it rotates more slowly. So yeah, in the summer, Earth literally chills a bit, spin-wise. Now you don't panic about your day suddenly feeling longer yet. Your clock is still gonna say 24 hours. That's just how our timekeeping works. As for these differences, they're milliseconds. You'd never feel it. But the problem is that over time, it all adds up. If the planet ever spun slow enough that we were off by more than 0.9 seconds, then we'd have to do something. That's when the International Earth Rotation and Reference System Service steps in. These are the people who keep tabs on Earth's spin, and if things drift too far out of sync with our clocks, they throw in a leap second to fix it. Yep, they literally add a second to the clock every now and then to keep Earth time on track. It's like the universe's version of a software update. In any case, with the moon slowly drifting away and Earth calming down, the fact that our planet is suddenly picking up speed, even just a little, makes experts and ordinary people raise their eyebrows. It's a reminder that even something as basic as a day isn't set in stone. The planet's moving quicker. Time is literally slipping. Something's shifting.
Now, if you were to check out the Sahara from space right now, instead of a barren wasteland, you'd spot a surprising sight. Dry land sprinkled with some lakes and rivers in Morocco and Algeria, all thanks to some heavy rains in early September 2024. These aren't oases. This is just the Sahara going back to the factory settings. Believe it or not, eons ago, one of the biggest deserts on Earth was actually a lush paradise full of greenery. Let's first see how the Sahara turned into a desert. During the last ice age, Earth was much colder, and big ice sheets covered a lot of the land. At that time, the Sahara Desert was significantly bigger than it is today, and on our planet there were fewer tropical forests. And the cooler temperatures changed how rain was distributed in the tropics. Now, normally, warm air rises in the tropics, which helps create rain. Since it was colder during the Ice Age, this system got, messed up, and less rain fell in some areas. This caused more dry and desert-like conditions in places that are usually wetter. There was also a lot of dust blowing around in the Sahara Desert, which scientists found in old ocean sediments. But about 12,500 years ago, something surprising happened. The dust levels went way down. This meant that the Sahara got a lot wetter, which is a sign that the climate suddenly warmed up for a while before cooling down again. After 12,500 years ago, the Sahara became a much greener place, like a savanna, because a weather pattern called the Intertropical Convergence Zone, a mouthful indeed, moved north during summer. This wet period was at its best around 4,000 years ago, when temperatures were a bit warmer than today. At that time, more rain fell in the Ethiopian highlands, which made the Nile River carry more sediment. However, there was another big change called a Heinrich event, which caused the Intertropical Convergence Zone to move back south. This led to the Sahara and Arabian regions drying out quickly. Because of this, the Nile River had much less flooding between 2700 and 2100 BCE. Long story short, too late for that. The Sahara has gone through wet and dry cycles due to changes in the climate and weather patterns over thousands of years. Up until recently, we've known about the Sahara in its dry era. But in September 2024, an unusual cyclone rolled through. It hit Morocco, Algeria, Tunisia, and Libya, and filled those dry lakes and rivers. The satellite images from NASA of before and after the rains are stunning. It's like the Sahara has had a makeover. Some areas in North Africa received up to 8 inches of rain. For comparison, Seattle gets about 40 inches per year, only 5 times what the Sahara received. I say only for one simple reason. Seattle has a reputation for being quite rainy, while the Sahara does not. The tricky part is those 8 inches. Essentially, the entire yearly quota for this area fell in a matter of moments. So, in a way, it might have felt rainier in the Sahara than in Seattle. The mountains funnel the water into ephemeral lakes in northern Algeria, which recently expanded to over 70 square miles and reached depths of more than 7 feet. That's enough water to sustain it for a year. So what exactly are these ephemeral lakes? Well, they're basins that fill up for a short time each year, but might stay dry for several years if the rain doesn't cooperate. Sometimes water flows into them from a small surrounding area, or it can just be good old-fashioned rain. Now, a big question arises. How come these lakes exist in the first place? Well, generally they form because there's excess water trapped on the surface. But the soil in the Sahara is incredibly dry. Shouldn't it act like a sponge? It must be thirsting for moisture. Well, think about how eagerly your potted plant drinks up water when you return home from a vacation. However, no matter how parched it is, dry soil can only absorb a limited amount of water, which is often quite small. And just like your potted plant, it doesn't necessarily drink it all. You might simply be overwatering. Or if you check the saucer below, you could find a mini flood. Another significant factor preventing the soil from absorbing water is the lack of vegetation. Under normal conditions, trees, shrubs, and various plants help retain moisture. In the desert, however, it's nearly impossible. There may be a few palm trees, but that's about it. This also explains the formation of those temporary lakes. Precipitation that isn't held by plants accumulates in low-lying valleys and depressions, creating these fleeting bodies of water. These lakes may only last for a limited time, but that doesn't mean they shouldn't have names. For instance, the beautiful lake adorned with swaying palms that you see is called Lake Yasmina, located in the oasis town of Merzoga. In certain areas of the desert, where the dunes rise, it may appear as though you're looking at a mirage, but it's not. The sand dunes are partially covered by water. Remember how I mentioned 8 inches? Well, that's not entirely accurate for some regions. In fact, there are places where the flooding is so extensive that the palms are submerged up to their crowns. Now, the last time we saw a downpour this intensive was 30 to 50 years ago. But this rain is more than welcome. After 6 consecutive years of drought, Morocco really needed it. Lakes that had been dry for decades, like Lake Ariki, are finally getting some much-needed water. A recent analysis revealed that out of the hundreds of storms that have hit the region since 2000, only 6 brought enough rain to start filling up this lake. And of those, only 2 resulted in a lake level higher than what we saw in September 2024. So while this torrential rain seems like a blessing, the big question is, will it last? The answer is yes. When humid air from near the equator meets the hot, dry air from the north, the Sahara Desert tends to get more rain. Scientists say this collision zone is shifting further north as the planet warms, and it warms, so it's likely to keep moving that way over the next couple of decades. So I seem a bit overly optimistic about this, and the truth is, the news isn't entirely positive. The reality is that no one was truly prepared for a flood situation like this. Moreover, remember that this isn't some Southeast Asian country where people are accustomed to dealing with water. This is the bone-dry Sahara. That said, I think you know what I'm getting at. Tragically, at least 18 people lost their lives to the intense rains in southern Morocco. The authorities are gearing up for even more heavy rain in the region. But if that's the case, could it mean the Sahara is facing extinction? And what would that even mean for us? It might sound a bit strange, but our planet actually relies on deserts, and the Sahara is no different. At first glance, it may seem like a barren wasteland, and it's nothing to write home about. But deserts play a crucial role in our ecosystem. They act as major carbon storage sites and are considered net carbon sinks, with the Sahara alone holding an estimated 1 trillion metric tons of carbon. In the fight against climate change, these existing deserts are like a buffer, helping to keep the temperatures within acceptable levels. Yeah, deserts are scorching hot, but they act as the world's air conditioning. Plus, desert sands are an unexpected source of nutrients for lush areas like tropical rainforests. Believe it or not, scientists have found that the sand particles from the Sahara have a hand in nurturing the Amazon rainforest. These particles travel across the Atlantic Ocean, riding the winds all the way to South America, where they enrich the soil in the Amazon basin. Without the Sahara, experts believe the Amazon rainforest could face serious collapse.
Mars can be secretly messing up the depths of our oceans. The red planet is 140 million miles away from Earth, so we once thought that it couldn't have much of an impact on us. But that changed recently with the discovery of some kind of butterfly effect. What starts with a small gravitational pull in space ends up creating giant whirlpools down here. This suspicion began when scientists decided to explore almost 300 deep holes drilled in the ocean floor, which were made back in the 60s. Their goal was to understand the strength of deep ocean currents by analyzing sediments. Materials like sand or mud that accumulated at the bottom of the ocean over the last 65 million years. The bottom of the ocean has layers upon layers of sediments. When these layers show a continuous pattern, it means that the materials have been gradually layering over time without any sudden interruptions. In other words, deep currents were calm and stable. But the researchers also noticed a strange pattern. During specific time periods, they couldn't find any records of sedimentation, which means that something else was interrupting this process. The most likely reason for these gaps was the presence of intense currents at the bottom of the sea. Because they were so strong, they probably moved sediments from their original spots. But here's the weird part. All the gaps identified in the study occurred at intervals of exactly 2.4 million years. The data showed a total of 27 gaps. That can't just be a coincidence. So the scientists realized they were not checking simple breaks in the sedimentation process, they were analyzing the presence of cycles. According to experts, the only plausible explanation for them lies in space and is probably the result of something known as the astronomical grand cycles. To understand this process, we first need to mention the Milankovitch cycles. They're named after the Serbian scientist who suggested a century ago that changes in the way Earth moves around the Sun and tilts on its axis can affect Earth's long-term climate. The thing is, the movements of Earth can be affected by many things, including other planets. Normally, our planet's orbit around the Sun isn't a perfect circle, but it's pretty close. However, from time to time, this path is directly affected by the gravitational pull of Jupiter and Saturn. So it's kind of like these two giant planets can pull our orbit, causing it to become more elliptical. Variations like this can affect the amount and distribution of sunlight, changing the climate here on Earth. According to the Milankovitch theory, Earth's climate patterns change in cycles of 405,000 years, 100,000 years, 41,000 years, and 23,000 years. And the theory is that these cycles might trigger the beginning and the end of glaciation periods, also known as ice ages. His theories were actually confirmed in the 70s by scientists who were also looking for evidence of these cycles in ocean floor sediments. Recent calculations have shown that besides the Milankovitch cycles, there are climate changes that follow much slower rhythms. They don't change every tens of thousands of years. Nope. We're talking about periods that stretch out over millions of years. And this is exactly what the astronomical grand cycles that I mentioned earlier are about. We know about such events basically because of evidence based on mathematics and computer modeling. But it is really hard to find any geological proof of the existence of these million-year astrological cycles, or any clue of how they affect Earth. That is, until now. Turns out, what scientists found at the bottom of the ocean could be just the proof we needed. And that's because the 2.4 million period lines up exactly with records of interactions between Earth and Mars. As the two planets chart their orbital paths, their gravitational fields interact in a process known as resonance. Yep, exactly like what happens with Jupiter and Saturn. From time to time, the gravitational forces of the red planet pull our orbit a bit closer to the Sun. And just like the shorter Milankovitch cycles, this grand cycle also affects our climate. In this case, by increasing the solar radiation that reaches Earth, making our planet warmer. To be honest, experts believe that this amount of extra solar radiation that Mars can somehow give us is not that big of a deal. I mean, it's not going to make our planet so hot that it will make us feel like we're stepping onto the sun. But this slight difference in climate can be enough to change some behaviors on Earth, such as ocean currents. Warmer climates tend to produce more frequent major storms, and that often produces sediment-stirring eddies, also described as giant whirlpools, which can reach the seafloor at the deepest parts of the ocean, known as the abyss. Finding those gaps in the deep ocean sediment record is really impressive because it's probably the strongest evidence we have of the astronomical grand cycles. As I mentioned at the beginning of the video, it's all like the butterfly effect. Every 2.4 million years, Mars's gravitational pull shifts Earth's path around the Sun, causing our climate to warm up. And when the planet is warmer, it can lead to the formation of large whirlpools, which end up turning the deep ocean waters upside down. And there's one more thing. The cycles found in the research also line up with already known periods of warmer climate throughout world history, like the famous Paleocene-Eocene thermal maximum. This event took place around 56 million years ago, when Earth was warmed by about 14 degrees Fahrenheit. Loads of theories have popped up trying to figure this out, like a glitch in Earth's orbit or maybe the passage of a comet. But with this new study, it looks like Mars could also be involved in this event. These new findings are pretty convincing and exciting, sure, but scientists still need to do more work to link these possible cycles of climate change with deep-sea currents. I mean, they did a good job of finding an explanation for the sediment gaps, but so far, it's just a suggestion. Their success is really important for the whole scientific community, though. After all, knowing when exactly these astronomical grand cycles happen and how they affect Earth can help us a lot, especially to differentiate when climate change happens due to a natural event and when it occurs due to human intervention. Studying these whirlpools can also provide scientists with crucial insight into how climate change affects ocean circulation. So, another reason why this finding is so crucial has to do with the potential collapse of the Atlantic meridional overturning circulation. In short, this is a system of ocean currents that circulates water within the Atlantic Ocean, being responsible for bringing warm water north and cold water south. This is what brings warmth to different parts of the globe and also carries nutrients necessary to sustain ocean life. However, there are some fears that this system might stop or become too slow anytime soon. If that happens, oxygen-rich surface waters would no longer mix with deeper waters. But the good thing is that this possible link between Mars and Earth gives a positive take on this situation by suggesting that in a warmer world, more intense deep ocean currents may prevent our seas from stagnating. But again, it's just a suggestion. The evidence is still thin. Some skeptical experts like to point out that although eddies have indeed become more active over the past few decades, satellite observations have shown that their currents aren't always able to reach the seafloor and maintain an effective water circulation. For now, all we know is that it's hard to say who is right. Only the following studies will tell. Around 5.3 million years ago, a crucial event reshaped the Mediterranean region. It was a colossal flood that refilled the local sea, which had been extremely barren and salty up until that point. It got the name Zanclean Flood, and it forever changed the geography of the area. The Mediterranean Sea is surrounded by Europe, Africa, and Asia, and connects to the ocean by the Strait of Gibraltar. This is quite a narrow passage, measuring about 8 miles. It may not be that wide, but the strait plays a crucial role in maintaining the liquid balance between these two bodies of water. About 6 million years ago, a bunch of things might have caused the Mediterranean to be cut off from the Atlantic Ocean. Some say it was an ice age. Others speak of tectonic movements, like earthquakes. Whatever the cause, it pushed the Mediterranean area into a period called the Mycenaean Salinity Crisis. For about 1,000 years, the sea slowly evaporated, leaving behind a dry basin that was several miles below sea level. This crisis really changed the landscape, creating conditions similar to those found in today's Dead Sea. What this means is that the lush Mediterranean beauty used to be a super salty environment, containing nearly 10 times more salt than the ocean. Say you could have visited. You would have been able to effortlessly float on the little water you could find, even if you're not a skilled swimmer. The amount of salt and that mineral content would have made it challenging for most creatures to survive. However, some hardy microorganisms, such as bacteria, could have adapted to these harsh conditions. These days, at the bottom of the Mediterranean Sea, we can find holes as large as the Grand Canyon, and they seem to have formed during that same period of dehydration. Evidence suggests that massive rivers, such as the Nile and the Rhone, flowed directly into the Mediterranean back then, leaving behind canyons as they reached the bottom, thousands of feet below the sea level. People had to find some sort of explanation back in the day for the drying of the Mediterranean, so they came up with myths and legends. One such tale was told by the people of southern Iberia, in modern-day Spain and Portugal. It was also recounted by a famous Roman writer called Pliny the Elder.
What this legend said was that the Mediterranean used to be cut out from the ocean until the hero Hercules, with his mighty sword, carved a path. He did so between a fictional location in modern-day Africa and the Rock of Gibraltar. This allowed the ocean waters to flow in, transforming the Mediterranean into what we know today. Some fossils also seem to confirm the unusually large flood. Remains of marine organisms were found in layers high above current sea levels. This means the areas were once submerged underwater. These fossils belong to mollusks, fish, and marine mammals. Because of modern techniques, we now have at least an estimated timing of the Zanclean flood. Scientists used computer simulations to reconstruct the event, providing further evidence that it was real. What they also discovered is that there's a possibility the Mediterranean might change once more. The Strait of Gibraltar could close, most likely because of movements deep under the ground. This could lead to the Mediterranean becoming dry again, over a span of about 1,000 years. The Mediterranean area could disappear altogether if the African continent keeps shifting north too, getting closer to Europe. Another one of those famous yet still a bit hypothetical large floods is called the Black Sea Deluge theory. Some scientists think that around 8,400 years ago, water from the Mediterranean might have spilled over into the Black Sea through a narrow passage called the Bosporus Strait. This could have caused a massive disaster, forcing people living near the Black Sea to pack up their things and move further inside the continent in both Europe and Asia. Along with them, they might have carried stories about this colossal flood. The specialist that came up with this idea also suggested that these migrating people might have brought along new ways of farming. Not everyone from the scientific community is convinced though. Some argue that while there might have been a flood, it likely happened earlier and was way smaller. They didn't think this flood could have caused, for example, the story of Noah's Ark. In this legend, a spiritual man was warned by a higher entity that a giant flood was on its way. The man went to gather pairs of animals and pack them all in a boat to make sure these species would survive the devastating flood. There was also the concern among scholars that discussing real floods and ancient stories too much might blur the lines between science and fiction. There may be other reasons why these flood stories are so often found across different cultures all over our planet. One idea is that floods were incredibly destructive for early farmers, so they invented myths about them signaling the end of the world. Another idea is that people stumbled upon ancient sea creature fossils in unusual places, leading them to believe there was a significant flood in the past. The solution to future floods, though, might be floating cities. As sea levels continue to rise, coastal cities like Amsterdam, New Orleans, and Venice may go under. So, floating infrastructure may be the way to go, with buildings that can rise with the water levels, making them able to resist extreme weather too. Countries like the Netherlands, which have a history of managing water risks, are pioneering these floating creations. With cities running out of space for expansion, we might be forced to move on water anyway. By moving on the water, we can reduce crowding and create more interesting ways to feed ourselves, like floating gardens. These homes also come with great alternatives to our energy needs through systems that use solar and wind power. Not to mention that these homes might turn out to be cheaper in the long run. One such floating city might pop up soon in the Maldives. Its goal is to host up to 20,000 people and will feature places to live and eat, but also shops and schools. Designed to look like coral, the region will include canals placed between some 5,000 floating pieces of land. The city will be constructed using modular units, put together in a construction site nearby. After they're completed, they'll be towed to the floating city. The next step is to secure them to a large underwater concrete hull, which is screwed tightly to the seabed on some steel stilts. All these pieces of construction let the modular units easily move as naturally as the sea. Even for those that are afraid of seasickness, there's a solution. That's what the nearby coral reef is for. It will surround the city, making a natural wave breaker. Human-made coral banks will also be placed underneath the city, which will also help coral grow naturally. The long-term goal is to make the establishment self-sufficient. It will have electricity, mostly from on-site solar power. Waste will be treated nearby and reused as plant fertilizer. Instead of air conditioning, the city will use deep-sea water cooling. This method pumps cold water from the deep sea to cool the area, saving energy. Earth is not the only planet that's seen some serious floods. In ancient times, Mars seems to have experienced them too, and they played an important role in shaping its surface. Recent research reveals that billions of years ago, Mars was heavily affected by some serious river flooding, which contributed to the formation of its valleys and canyons. The reason for these floods was heavy rainfall, which reshaped the Martian landscape in a jiffy, at times even within days or weeks. Unlike Earth, where rivers form pretty slowly, Mars experienced rapid changes because of these floods, particularly around 4 billion years ago. We've known for quite some time that there have been floods on Mars, but this study really showed us their extent. We now know they were more widespread and frequent than previously thought.
Ever wondered what Earth would look like if it was split evenly between land and water? I mean, like 50% land and 50% ocean. Like a cosmic pizza with just 2 toppings split equally. First things first, we all know that water is essential for life. That's why scientists search for water on other planets to find potential life. On our own planet, water covers about 71% of its surface, with most of it found in the oceans. What if we took away almost a quarter of that water and replaced it with land? If we did balance out the land-to-water ratio, we would see some pretty drastic changes. Due to the sea level drop, regions around the North and South Poles would dry up completely. Meanwhile, every continent on the planet would expand to reveal an enormous amount of new territory. This would be equivalent to the current surface areas of Asia, Europe, Africa, and North America combined. Imagine all those new vacation spots you could explore with all that land. This shift in the ratio of land and water wouldn't be all sunshine and rainbows though. With much less water covering the surface, our ocean currents would get messed up, leading to a destabilized climate. This would mean colder temperatures around the poles and even hotter temperatures in the already scorching equatorial regions. Rain levels would drop, creating dangerous droughts and new deserts in many inland areas. Let's not forget about the creatures living on Earth. Plants, animals, and humans would all need to adapt to being less dependent on water. Some animals may even evolve to be smaller or switch to a strictly carnivorous diet due to water scarcity. And sadly, lots of life forms in our current oceans would struggle to survive, which would be a huge bummer for all the fish lovers out there. Let's try to imagine a totally different scenario for our planet next. Back in 1884, the press reported on an astronomer who claimed to have discovered a cubic planet beyond Neptune. We've sure come a long way since then. We've come to know that in our universe, there's no possibility of planets being square, at least based on the information we have today. Let's travel back in time to 4.5 billion years ago when our own planet was just a hot mess of gas and dust. As this chaotic cloud collapsed, a hot star formed and began to attract all nearby matter with its gravitational pull. Eventually, a rotating disk formed around the star, and collisions between particles led to the formation of massive bodies, planets. And because gravity pulls equally from all sides towards the center, planets naturally take a spherical shape. But what if we spice things up and skew the distribution of gravity? Well, if you're feeling adventurous and want to live life on the edge, then welcome to the Cube Earth. Yay! We'd have 6 sides now, but don't get too excited. None of them would be any fun. You'd constantly feel like you're climbing up a steep hill, no matter where you go. That's because gravity is strongest at the center of each face. So the further away you were from the center, the stronger pull you'd feel. Say goodbye to taking standing tall for granted. If you found yourself on the edges of the Cube Earth, you'd find no lush and vibrant landscapes. All the water would pool at the center of each face,
leaving the edges rocky and barren. And forget about breathing easily. The atmosphere along the edges and corners would be too thin or non-existent to support life. But we'll come back to that later. The climate on the cube Earth would depend on how it would rotate. If it spun on an axis through two faces, then the climate would be similar to what we have on Earth now, but more extreme. The top and bottom faces would be polar, while the other four would enjoy an equatorial climate. However, if the cube Earth rotated through its corners, each side would have a climate with more moderate temperatures and precipitation. Say goodbye to extreme weather, but also wave goodbye to your equatorial paradise. On the bright side, you would probably be able to walk into outer space. Since the atmosphere is held down by gravity, and gravity would now be pulling towards the center of each face, the atmosphere would be thicker there and thinner towards the edges. If the cubic Earth had the same volume as our round world today, its sharp corners would poke out beyond our atmosphere, creating unprotected and uninhabitable areas. But who says you wouldn't be able to rent a spacesuit and stand on top of the world and outside of it at the same time? Talk about taking your vacation to new heights. How about if our planet was completely covered with water? Well, it turns out that ancient Earth might have been just that, a water world. According to some researchers, our planet was mostly covered with oceans about 3 billion years ago, with only a few scattered islands popping up here and there. The scientists who made this discovery have been studying rock samples found in Western Australia. By analyzing these rocks, they were able to determine that they formed in a hydrothermal vent system on the seafloor over 3 billion years ago. This information could have some major implications for how we understand the origin and evolution of life. See, scientists still have a lot of questions about where Earth's water came from and when it appeared. But by studying these ancient rocks, they're hoping to get some answers. One way they're doing this is by looking at the oxygen found in the rocks. You see, water with different values of oxygen can tell us a lot about the environment in which it formed. And the researchers found that the rocks from 3 billion years ago had heavier oxygen content than we see in our modern oceans. This suggests that at that time, dry land hadn't emerged yet, which means that Earth was mostly covered in water. Now, this might not seem like a big deal, but it could actually help us understand how life first formed on Earth. If our planet was completely covered with water when the first single-celled organism emerged, then they probably didn't form on land. And if that's the case, it could mean that other water-covered planets might be ideal places to search for life. Our planet may never be fully covered in water ever again, but we might end up losing some, if not all, of our planet's hydration. Here's the deal. The sun is going to get hotter over the next few 100 million years. This isn't anything to do with humans and our shenanigans. It's just a natural thing that happens with all stars. The bad news is that the sun gets hotter, our planet is going to heat up too. And if things get really toasty, we're going to start losing our oceans to evaporation. Sure, we've got plenty of time to hit the beach before that happens. Experts have been working hard on a super fancy computer model to predict exactly when all this is gonna go down. And according to them, we've got around 1 billion years until things get seriously steamy. You might be wondering how they came up with that number. It turns out that when the sun gets hotter, it makes the atmosphere warmer too. And as the atmosphere warms up, more and more water evaporates from the oceans. There's a catch though. Water vapor is actually a greenhouse gas, which means it traps heat and makes things even hotter down there on the surface. As we lose more and more water, we're going to end up in a loop where the planet just keeps getting hotter and hotter until there's no water left at all. But hey, it's not all about us. This research could actually help us find other planets with liquid water. By figuring out what kinds of conditions are needed to keep water on a planet, we might be able to identify some other hospitable worlds out there. And who knows, maybe in 1 billion years, we'll have colonized one of those planets.
Not an earthquake, but a mega earthquake could happen in Japan. It's scarier, bigger, and more destructive than ordinary tremors. However, the problem is that it will occur underwater, which means it will trigger a giant tsunami 100 feet high. A column of water nearly as high as a 10-story building will collapse on coastal cities, wiping out hundreds of houses. The water flow can destroy everything in its path like a bowling ball that knocks down pins. And then another wave may come, and another one. Anyone who is at risk should be on their guard. How to survive? You'll find out later in this video. But first, let's find out what a mega earthquake is. This is an earthquake with a magnitude 9 or more. This is a very rare phenomenon, and it depends not on the power of the shock, but on the length of the fault where it occurs. The longer the fault, the stronger the earthquake. But what are these faults? These are cracks in the rocks of the Earth's crust that move relative to each other. Imagine a large puzzle where every detail is a giant tectonic plate. When one part of the puzzle moves away from another or when they collide, that's when earthquakes begin. If the fault between the parts is long, then the magnitude of the earthquake is great. The largest mega earthquake ever recorded occurred on May 22, 1960, in Chile. The fault was almost 1,000 miles long. It's almost half the way between Chicago and Los Angeles. And now, a similar mega earthquake can happen underwater. That's how it all started. Last year, on August 8th, at 4:42 p.m., an earthquake with a magnitude of 7.1 occurred in southern Japan. The tremors appeared off the coast of the mainland island of Kyushu. Everyone was terrified as they expected a large tsunami to appear. But fortunately, they faced only a small wave. It collapsed on the shore, but didn't destroy buildings. About 15 people got hurt, which is sad, of course. But it could have been worse. It seemed that the disaster had passed. The residents breathed a sigh of relief. However, after that, the Japan Meteorological Agency sent a warning about a possible mega earthquake that could be incredibly devastating. A previous earthquake of 7.1 magnitude could be a harbinger of an impending catastrophe, a disaster that could affect 250,000 people. As soon as people heard this, they ran to buy groceries. Increased demand and a slight panic led to shortages of rice and several other basic products. People were stocking up on food and preparing for the worst. But a week later, the Japan Meteorological Agency canceled the warning. It turned out that the small tsunami on Kyushu Island was not a harbinger. No one knows whether a mega earthquake and tsunami will happen in this region, but the chances are very high. To understand the nature of this danger, we need to dive underwater in a place called the Nankai Trough. It is a 500-mile-long underwater fault that runs almost parallel to the Pacific coast of Japan. This is where the two giant sections of the Earth's crust meet, the Philippine Sea Plate and the Eurasian Plate. And the Philippine Plate is subducting and slowly slipping under the Eurasian Plate, on which Japan is partly located. During this movement, the plates get stuck, accumulating energy. Afterward, when they move and align again, they release a powerful burst of energy. And this energy is capable of causing one of the most powerful earthquakes in the world. Experts report that the probability of a mega earthquake and a tsunami is about 80%. Over the past 1,400 years, mega earthquakes have occurred every 100 to 200 years in this region. The last time this happened in Japan was in 1946. The entire country felt a powerful tremor that destroyed 36,000 houses in the southern part of Honshu Island. Every year, the probability of a repeat of this disaster increases by 1%. And do you know how many years have passed? 79. According to experts, a mega earthquake with a magnitude of 8 to 9 can trigger a tsunami that will flood small islands off the coast of Japan. And areas with large populations on the islands of Honshu and Shikoku can be flooded in minutes.
hundreds of thousands of people are at risk. It can be billions and even trillions of dollars worth of damage. According to some reports, about 530,000 people may lose their homes. To save lives, the country needs to carry out a large-scale evacuation, but the problem is that no one knows the exact date. In general, no one in the world can predict in advance when the next big earthquake will occur. In the case of the Nankai Trough, it can happen in a few days, or a few years, or even centuries. So, what should people do? Prepare. Japan has been experiencing earthquakes for a long time, so the country has learned to survive a disaster with minimal losses. Almost every building in Japan is equipped with dampers, which are devices that suppress any vibrations and make houses more resistant to shaking. In addition, on the shores of Japan, residents have built long and high shields that don't allow powerful waves to break through to land. Japan also has an advanced earthquake warning system. It's impossible to predict powerful seismic activity in a few days or weeks, but it's possible to detect small tremors that may portend an impending earthquake. Special devices monitor seismic signals and transmit the data to certain programs. Then, they evaluate the magnitude and intensity of the tremors and send warnings to people's phones. This can save seconds and even minutes for locals to reach the nearest shelter in time. These systems are also used to slow down the speed of trains, to stop work at factories, hospitals, and office buildings. It's much safer for a train driver to slow down during an earthquake than to rush forward at full speed. But what if you're on the street and you can't hear your phone messages? How to act in case of disaster? This applies not only to Japan, but also to any place where a tsunami or earthquake may occur. To survive a tsunami, you need to prepare for it long before a big wave hits. It's very important to have good relations with neighbors. Be friendly with them, help them, and treat them well. In times of trouble or disaster, it's great to have people with whom you have a good relationship. They can help you get out of a difficult situation, and you can also help them. Be kind and compassionate to people. This way, it's much easier to survive any disaster. Prepare a backpack with necessities in advance. These are a first aid kit, canned food, flashlights, a battery-powered radio, and bottled water. All this will not only save your life, but will also help other people in trouble. So if you feel an earthquake start, immediately run for cover. If you're at home, try to stand against a wall closest to the center of the building, or crawl under heavy furniture that stands firmly on the floor, such as a desk or a regular table. Stay away from windows and front doors, and never use an elevator. If you're on the street, don't come close to power lines and any objects that may fall. During a tsunami, you may need to get as high as possible to avoid getting swallowed by water. Stay as far away from the shore as you can, and don't go down until you're sure it's safe. But how can you find out about an approaching wave if you haven't received the warning? When a tsunami approaches the shore, you will hear a roar similar to the rumble of a passing train or plane. If there's no elevation nearby, then try to get to the upper floors. It must be at least the third floor, but it has to be a building that can resist a tsunami, such as a massive house made of concrete. If there are no such high buildings nearby, try to climb a massive tree. When the disaster is over, look around and find those you can help. Listen to messages from rescuers via radio or TV. If all is well, then you can deal with the consequences. Yes, there's a lot of work ahead, but you've survived and helped others survive. And that's the most important thing.